All right, so we're going to take a look at multiplying binomials. And I just want to mention another word that they may use when you're taking a test is instead of multiply, they're going to say find the product. Okay, those mean the exact same thing. So what we're going to do is we're going to type it into Desmos. That way we can do our work or check our work as we are doing our questions. So just go ahead and type in the question: x minus 7, x plus 10. Okay, so now I'm going to multiply each thing. To multiply each thing, you're going to multiply this and multiply it to everything here. So this one should have two things. Then after you finish that, you're going to take this part, which is the second piece, and you're going to multiply it here, and you're going to multiply it here as well. So this one should be two things as well. So you should have a total of 4 separate multiplications. So let's start at the beginning. X times x, that's what we're doing. X times x is equal to what? X squared. There are 2 of them, right? So x times x is equal to x squared. And you can see that what I'm doing is I'm checking my work as I go. X times x is equal to x squared. They match. So what that means is I can replace, and this is where I'll put my answer. I can replace x times x with x squared. All right, so that's my first multiplication. My next multiplication is going to be x times positive 10. So again, using Desmos, we're going to check that. So I'm going to hide everything. X times positive 10. Okay, so now I'm going to put this in here. That's going to be 10x. Is that matching? Yes. So x times 10 is 10x. So now I'm going to put that here. Okay, so that's my second multiplication. I'm going to unhide this so I can go to the next one. So I've taken this and I've multiplied it by everything. Now I'm going to do this one. Negative 7 times x. Negative 7 times x. And what's that going to equal? Negative 7x. And again, it matches, so that's fine. So I'm going to take negative 7x, my term here, and put it here. And I got one more left. Okay, then I'm going to hide this. All right, my last one should be negative 7 times positive 10. So we're going to go ahead and do that. Negative 7 times positive 10. That's going to give me negative 70. So I'm going to type that here, negative 70. So I'm finished because I have 4 terms because I have 4 different multiplications. Now that I'm finished, I'm going to see if it matches. I'm not done with the question, but does it match? These are both red, so hold it down. I think it's hold it down. Yeah, then just change the color. Perfect. All right, so I'm not finished with the question, but this is the first piece of the question. And now that I see that it matches, I know that I'm okay. So my final step, okay, so now that it matches, is to combine like terms. Those are terms that look alike. Does anything look alike with x squared? Is there another x squared term? No. Does anything look alike with positive 10x? Yes. Negative 7x looks alike to positive 10x. So we're going to combine these like terms. So I'm going to press enter. This is going to be my final answer. And here I'm going to do the work. What is positive 10x plus minus 7x? So 10 minus 7 is 3. So I think it should be 3x. So I'm going to check to see. I'm going to hide these again. Does it match? Yes, it does. So black matches with blue. So I've done this correctly. So I'm going to replace the middle piece. So I'm going to take all of this, replace the middle with positive 3x. And if I do that correctly, it is going to now match. So I can delete my work here. And now I need to check all of it. So does this match this, which matches my final answer? This. Yes, it does. So this is now my final answer. Now I'm going to do another example. I'm just going to go a little bit faster with it because obviously with that one I was taking my time to make sure that you understood. All right, so again, step 1 is we're doing all our work in Desmos so we can check our work as we go. Copy your question in there. So 2x minus 2 and 3x minus 5. All right, you're going to have 3 answer lines. All right, so one where you multiply them with 4 terms and then one where you combine them. And then I'm just going to put all my work here. So let's start multiplying. 2x times 3x is 6x squared. And again, I can check that, right? 2x times 3x. I want to hide these real quick. And I think that that is going to be 6x squared. So I'm going to zoom in here and I'm going to click that. Does it match? Yes, it does. So I did that correctly. Okay. Now my next one, 2x times negative 5. So 2x times negative 5. And I think that's going to be 2 times negative 5 is negative 10. So negative 10 and then x. Okay, so I'm going to hide this real quick and say, does this match? Yes, it does. So I did that correctly. All right, my third multiplication. So I finished multiplying this one. My next one is negative 2 times 3x. Negative 2 times 3x. And that's going to be negative 6x squared. Negative 6x. And if I've done that correctly, again, it should do what? Match. So there's my black line. Yes, I did. So this term is correct. So I'm going to put that over here. My last multiplication is negative 2 times negative 5. Negative 2 times negative 5. And that gives me positive 10. And again, if I've done all of this right, so if I did my 4 multiplications correctly, this is going to match this, which it does. So because those match, I know that I'm good. I can keep going. My last part is to combine these two. So again, I'm going to copy the whole thing in here. Then combining these two things, I'm going to get negative 10 minus 6. Negative 10 apples minus 6 apples is negative 16 apples. I'm just going to delete the x's so you can see that. Negative 16. Perfect. All right, so now if I've done this correctly, when I put negative 16x, it should match. So again, it's going to match all three things. So let's check it. So we start with purple. Yes and yes. So this is my final answer. And I've been checking my work the entire time. So if you're doing this question in class and it doesn't match at some point, stop and come and see me if you can't figure it out. I'll take a look at solve by trinomial factor. It's the same as factoring, only difference is it's actually your solution, your x-intercepts, your roots, or your zeros. Okay, so solve is you copy the same, x out of everything extra. So control C, control V, and then here we're going to make it squared. Then we're going to control X, control V. All right, so let's take a look at the solutions. The solutions are the x-intercepts. What is it cross? Negative 2. And what is this? Oh my gosh, it's a fraction. So we just have to write it in. So solve the quadratic by factoring. So the first answer is going to be, where does it cross the x-axis? Negative 2. And this is asking you for an equation, so I'm not going to put it as a coordinate. So it's negative 2, comma, because there are 2 places, right? And then the next one is this, but I can't put that in here. So it's negative, but it's a fraction of some sort. So I got to find out what that fraction is. So I'm just going to put it in as negative 0. And it's 666 repeated. So remember, for this, the trick is put the fraction, do it until it disappears. Then when it reappears, that's your actual answer. So negative 2/3. All right, negative 2 over 3. Okay. All right, I'll do another one. So again, copy the question, paste it. All right, boom, make sure it matches. Okay, that's good. Go get your answers because it's asking you for the solutions. These are your 2 answers. So the first one is 1, comma. The second one is 2.5. But remember, we can't put 2.5 in there, right? So you're going to put 2.5 in here and make it a fraction, which is 5 over 2. So your 2 answers are 5 over 2 and 1. And I don't need to make these opposite because I'm not going in the parentheses, right? So you just copy and paste in and looking at what the solutions are. Where does it cross the x-axis? That's it. All right, so this is 5.C, create and solve quadratic equations in one variable, explain the solution, solve by inspection, taking square roots, factoring, completing the square, and applying the quadratic formula. All right, so today's question is right here, find the solutions to this. So we're going to go ahead and type it in. I have shown you how to do it by hand, but at this point, I'm just going to show you how to use your calculator as well. So you just go ahead and type in the question, boom. All right, so I'm going to zoom out so I can find the graph. And it looks like no matter, I'm going to hide this real quick. No matter how far I zoom out, there is no graph. Okay, so these are my previous notes. We talked about if it doesn't cross the x-axis, it has 0 solutions. If it only touches it 1 time, it has 1 solution. If it crosses 2 times, it has 2 solutions. So your options are 0, 1, or 2. Now, 9 times out of 10, I've put in some new notes for you right here. If a graph doesn't appear You're going to take everything to the left and delete the equal sign. All right, so let's go ahead and do that. So the graph did not appear. I'm going to hit home again. It did not appear. Take everything to the left and delete the equal sign. So I mean, this needs to go to the left. So right now I have positive 2x. How do I get rid of positive 2x? I subtract 2x, but I have to do it to where? Both sides. So I'm going to subtract 2x from that side and subtract 2x from that side. Now, what is 2x minus 2x? 0. So that's why that disappears. And then so it says, take everything to the left and delete the equal sign. Delete the equal sign. All right, so now it says there should be a graph, and boom, there it is. All right, so my question to you is, how many solutions does this graph have? Is it 0 solutions, doesn't touch the x-axis? 1 solution touches 1 time. 2 solution touches twice. This is the x-axis right here, so this has no solutions. So remember, there are cases where there's no solution. If that is the case, you're going to write no solution. So what is the solutions, or the roots, or the zeros, or the x-intercept? In this case, there is no solutions. So just remember, if your graph does not show up, it could be possible that's a no solution graph. And to get that, you need to take everything that's on the right to the left and delete the equal sign. You guys already know we've talked about how to factor trinomials from a calculator. I'm just going to give you a quick refresher before I show you how to do it by hand. These are the steps to do it by hand. I've gone ahead and typed in my equation, my quadratic equation, into here. So I already know that here are my solutions. Boom, those two are my solutions. So I'm going to write into factor form. I know that I should have 2 parentheses for factor form, or slope or intercept form, right? And as soon as I do that, you see it goes off whack because I haven't put it in. So the key thing to remember is that you take your solutions, your roots, your zeros, or your x-intercepts, and you change them into factored form. If it's going into the parentheses or out of the parentheses, you change the sign. So we're going to change this from -1 to what? +1. And we're going to change, and as soon as I did that, you see how that lined up? So I'm good so far. This one needs to go to -1.5, but we know we don't put -1.5 in there. We don't accept it. We have to have a what? A fraction. So you're going to click fraction. Now be careful. This is exactly 1.5. It's not -1.5555. So you got to read. If it was 555, right, you would look at this answer and be like, this makes no sense. What would you then do? You would keep going till the answer that makes no sense is gone, and then keep going until it comes right back, and this looks like a better number. But for this particular question, it is literally 1.5. That is what you're doing. What do I do now? So I can't write, all right, so you take the opposite. I can't write this. I have never seen a quad. It lines up, but this is not how we write it, right? So remember, you take your denominator and you put it where? In front of the x. That's all you got to do. You take your fraction, you take your denominator, put it in front of the x, and please make sure you change the sign. And as soon as you do that, you see my solutions have lined up. But here's the problem. This cannot be the answer. Why, Miss Ainley? Because the graphs just don't match, right? So we got to make these graphs match. And remember, we talked about if they don't match, it means that there's a what? A GCF. All right, the calculator is going to help you find the GCF. Don't remember how to type it in. At least just type in GCF and then click it. It says try using parentheses. Let's try using parentheses. GCF of what? Of the question. All right, so what are the numbers in this question? It is 4, 10, 6. And the GCF is 2. And all you have to remember to make these graphs match and to write in correct factor form is to put the GCF outside the parentheses. And as soon as you do that, what happened? It lines up perfectly. All right, so that's how you do it with the calculator. But now we're going to talk about how do I do the exact same thing but using my hands on my head. Okay, so no calculator basically. All right, so here are the steps. You're going to put them in standard form. So in other words, it needs to look like this: ax squared plus bx plus c. It already does look like that. There's ax squared plus bx plus c. Cool. All right, factor out the GCF. So we're going to factor out the GCF. We did that. You just type in GCF, blah, blah, blah. It's 2. All right, so the GCF of that is 2. And then it says, if you don't do this here, you'll get the question wrong. And write it where you will write your final answer. So we're going to go ahead and write it. So my answer is going to be 2. And I have 2 answer places right here. I'll just put it right here. Okay, so just write it where you put in the answer. And you could write it. You could write it over here as well. You know, what's the question asking you to find? How does most be helpful? Your work, your answer, and rate yourself. Okay, so boom. I put it right there. I can forget about it. Circle and label ABC in the question. So circle and label ABC. So if I took out the greatest common factor, I now have 2x squared left in the parentheses plus 5x plus 3. And that's just by taking out 2. When I take out 2, if I distribute it back in, I should get the original question back. So that's what taking out the GCF means. So this is A, this is B, and this is C, right? So label it. All right, don't forget the symbol or the invisible one. Okay, so what it's saying is, let's just make sure, let me change my color real quick, that I take the symbol with whatever the number is. And if there was a 1 there or nothing, it'll be an invisible 1 because it does exist. All right, fill out the top and the bottom of the X according to the picture. So here's the X. The top says A times C. So what's 2 times 3? 2 times 3 is 6. What is the bottom? Just B. So what's the bottom? 5. So we're filling out the picture just like what I see. All right. Find the factors. Okay, so these are factors. These are two numbers that multiply to AC. So they need to multiply to 6 and they add to 5. And so what you're going to do, and I think you can do this part in the calculator. Let's go ahead and do it. Factors. Let me see. Factors of, what are they? The factors of AC. So factors of, and again, we want to put parentheses or whatever you want. So A is 2 and C is 3. No, factors of AC. I'm sorry. I'm tripping. Factors of AC, which is 6. Okay, so no, that doesn't help me. Too many variables. Maybe factor of 3. Okay, I guess it's not going to let you down. So basically 1 times, so it's kind of like breaking it down. So you're going to do this. You're going to say, okay, 6 divided by, and you're going to check 2. Does that work? Yeah. So what we're saying is 2 times 3 is a factor. Okay, cool. Let's check another number. Well, there's no point in checking 3 because we already know. Let's check 4. 4 didn't work. Check 5. 5 didn't work. 6 works. So 6 times 1. So the only factors, and you can just go in order, is 6 times 1 and 2 times 3. So these are my factors, right? But they also have to add up to 5. So it says find the factors and multiply to AC and add up to B. All right, so now all I have to do, okay, is change the sign so that they can add. So I know both of these multiply to 6. So what I'm going to do is I'm going to take this first one. So once I take that first one, so this is 2 and 3. So remember, they already multiplied to give me 6. I now need to add them to give me 5. So I'm going to put plus. Oops, plus. Okay, I need them to be 5. Oh, look at that. So the first one, 2 plus 3 gives me 5. So 2 times 3 is 6. 2 plus 3 gives me 5. So my two answers, that actually works. My two factors, right, that multiply, so check the factors and fix the signs, that multiply to 6 and add to 5 are 2 and 3. So we're going to say 2, oops. So my factors are 2 and 3 because 2 times 3 is 6 and then 2 plus 3 is 5. And so just be careful and play with the signs. So if that wasn't it, what you would do is put a negative here. Does that give you the answer you're looking for? No. Put a negative on the second one. Does that give you the answer you're looking for? No. Put a negative on both. Do that give you the answer? No, it's close, but it's negative, right? So be very exact. So you're just going to change the signs of both of your factors and see which one works. But I already found it as 2 and 3. So now what? Now we're going to divide by A. So what is A? All right. So remember my A labeled is 2. So now you're going to divide by 2. All right, now put that in the calculator. 2 divided by 2 is going to give me 1. And then 3 divided by 2 cannot give me anything. And these are your solutions, okay? Only thing is you don't have to change anything because they're already done for you. So my factors are going to be x plus 1. And we already know that this needs to come to the front because it's a fraction. And this is 2x plus 3. And if you notice, that's the exact same thing we did when you did with the calculator. So if the factor is a whole number, just write your answer as GCF, x plus left, and then x plus right. If it's a fraction, then you need to remember to put your denominator, your left denominator, in front of the x, and then your numerator as what is left. Okay, so that's how you do it by hand. Difference of squares. So, and this only works if you have two terms. So this is the first one, this is the second one. And they're separated by a negative. So if they're separated by a positive, it will not work. But if you have two terms separated by a negative, and you can take the square root of the first one, and you can take the square root of the second one, then your answer is the square root of these two things, plus and minus. So for example, the square root of x squared is x. The square root of 144 is 12, and you can just put that in a calculator. So it's that plus and minus. That's it. Okay, so square root of the first thing, square root of the second thing with a plus and minus. All right. Let's do another question. So I'm going to do a couple of these. All right, so again, you take the square root of the first, the square root of the second, plus and minus. So this is x, square root of x squared is x, square root of 25 is 5, and then you're going to do plus or minus. Just like that. All right, I'll do one more, so I'll do the actual question. So I already know I'm going to have parentheses. Square root of the first one, so square root of x squared is x. Square root, so I'm going to do it twice, right? And then the square root of 81 is 9. So I'm going to have plus 9 and minus 9. Right? So again, square root of the first thing, square root of the second thing, plus and minus. And again, I'm going to do a few of these just to make sure that you're okay. So square root of the first thing, square root of the second thing. So let's square root this first thing. So square root of 36 is 6. Square root of x to the 6th power. Okay, so let's talk about that. What does x to the 6th power mean? It means you have x times x 6 times. Okay, x times x 6 times. And then when you square root that, right, remember square root is the opposite of squared. So you're going to go backwards. Squared is the same thing twice. So going backwards would be taking away the two things that you just got and making it one thing. All right, two things that you just did and making it one thing. Two things that you just did and making it one thing. So the square root of x to the 6th power is how many x's? 3 x's. So this is x 3 to the 3rd power. And then the square root of 49 is 7. So again, it's the square root of the first thing, the square root of the second thing with a plus and minus. Right, I'm going to do one more question on this because it's pretty similar. All right, square root of the first thing. Actually, I want a harder question. Let me see if I can get a harder one. Nah, I'll do this one. Okay. So again, your parentheses, square root of the first thing. So y to the 4th power. What does that mean? It means I have 4 y's, right? 1, 2, 3, 4. So every 2 of them is going to become 1 if I'm going backwards. Every 2 of them is going to become 1. So I'm going to have 2 total. So square root of y to the 4th power is going to be y to the 2nd power. And then plus or minus. And then the square root of the second thing. Well, the square root of 64 is 8. And again, you can just put that in the calculator. Hit 1, 2, 3, hit square root, and then hit 64 if you don't know the numbers. All right, so that one's 8. And then the square root of x to the 4th power. So again, that's having x how many times? 1, 2, 3, 4. And every 2 becomes 1, right? So that's going to be 1, and then that's going to be the second one. So it's going to be x squared. All right, so we're going to take a look at finding the square constant. And you can just quickly look right before this time. I do complete the square by hand, and I do this piece of it in there. So you can see why it's important, because they may ask this part of the question. So they may ask part of how to complete the square where you can't use a calculator. So you do need to know what it means. So the first step in completing the square when you have a quadratic function is you're taking the middle, the one with the x, you're going to divide it by 2, so negative 18 divided by 2, which gives me negative 9. And then whatever it gives you, you're going to square it. And notice I'm putting this in parentheses because if you don't, the calculator is going to do order of operations and not square the whole thing, but only square the 9. So this is 81. So complete the square. The first piece to completing the square is to take the middle term, the one with the x, divide by 2. So 10 divided by 2 is 5. And then square it, which means it's 25. All right, so again, take the middle term, the one with the x, divide by 2, which is negative 6, square it, it's going to be 36. Because anything squared, anything times itself, negative times a negative is a positive. A positive times a positive is also a positive. So it's always going to be positive for this one. Negative 20 divided by 2, which is negative 10, square it, is going to be 100. And you're just getting a score of 10 out of 10, and you're trying to beat that in 100 seconds. What we're going to look at right now is complete the square with an even b, and that just means that the number with the variable is even. That way we'll have no fractions in our answers. But just like everything else, I'm going to show you how to do this by hand. Like everything else, if you're given multiple choice, you're going to just go ahead and type it straight into the calculator. Before we do that, we're going to make one little correction. There was a typo here. We're going to cross out that 4. This was actually supposed to be the question. So let's go ahead and type the question into the calculator. And this just goes for any single thing you have that's multiple choice. Go ahead and type it up and see if you can find a match to it with the answer choices. So boom, there's my quadratic equation. Now I'm going to type in my answer choices. So there's my first one matched. All right, so my first answer should be A. All right, so now we're going to go ahead and do it by hand. Okay, so that's how I use the calculator, but also doing it by hand is also pretty quick. So we're going to go ahead and, knock that out. All right, so we're going to take the constants. And what is a constant again? Anything that does not have a variable. So that's going to be negative 18 and negative 6. Does not have a variable. Those are my constants. Take them to the right and combine them. All right, so I'm going to add 18 on both sides so that this goes to 0, and what I'm going to be left with is x squared plus 10x, and I'm going to leave a space here, and you're going to see why in a second, and put this in the calculator. 18 minus 6 is 12. Okay. All right. Take the constant on the other side and combine. I've taken the other side, I've combined them. Take b, and again, b is the number with just the x, so that's going to be the number with just the x. So take b right there. All right. You're going to divide it by 2, and then square that result. So take b divided by 2, square the result. So 10 divided by 2, so we're going to divide 10 by 2 is 5, and square that's going to be 25. And you're going to add that number to both sides. So I'm going to add it to this side and add it to this side. And again, I'm just going to show you that in the calculator. So again, you're going to take b, which is 10, divided by 2. Let's subtract Miss Ainley. Divided by 2 right there and square it. What's 5 squared? And if you want to square it here, don't do, wait, let's see if it'll work actually. Yeah, close the parentheses and then square it. It will work. Yeah, that's it. All right, so either do it separately on 2 different lines. So 10 divided by 2 is 5, so 5 squared is 25, or just close the parentheses and do it there. All right, so it's 12 plus 25, and again, you can use a calculator. It's going to be 37. So, I'm getting ahead of myself. Let me read the instructions. So we took divided by 2 squared, add the number to both sides. On the left, write this. So we're going to write x in parentheses. And then it says plus or minus depending on what b is, right? So what's b? B is positive. So I'm going to write positive. And then b divided by 2. So only b divided by 2 here. So 10 divided by 2, which is 5. Close the parentheses and then square. And on the right, combine the constants, which we just said was 37. Okay, and that's it. So that answer, you can see, matches with A. So doing it by hand is just as easy. The first step is to make sure all the constants are on the right, combine them. Then you're going to take the one with the variable with just x. You're going to divide it by 2. It's going to give you the answer here. Square that, which is going to be 25, and add it to both sides, and you're done. All right, so we're going to copy and paste it into your equation. And look, there's an error. What's the problem? We only support implicit equations of x and y. Oh, because I put a w in here. So let's change all the w's to x. But when you put in your answer, just make sure you're using w or whatever the question says. X, perfect. So here are my solutions right here. Now, here's the problem. If my solutions was something that were repeating decimal, then I would be fine. But these are not repeating decimals. So my answer is irrational. And here's the hint that says a plus or minus. So I actually have to do this the long way, but I can do it using the calculator the whole time. All right, so I'm going to keep my original question here. I'm going to do Control C, Control V. All right, I'm going to do my work in decimals. Notice purple and red, same question, right? All right, so we're going to put this into the quadratic formula. To put it into the quadratic formula, remember you have to have equals 0 on this side. So what do? Take this to the other side. So if I take 6x squared to the other side, it's going to change from positive to what? To negative, right? So I'm going to x out of that, put it right here, and put negative. Now, did I change anything? So let's get rid of this equals, so because that's equals 0. Did I change anything? Look, it looks exactly the same, right? So all I did was take this to the other side. Now let's combine like terms. So I have 11 minus 6. So 11 minus 6. So it's 5. All right, so let me change this whole thing to 5x squared. Did I change anything? So look at it. Okay, so we're just using the calculator to still do our work. Now I can see this is an ABC form. Once it's in ABC form, I can just go and put it into the quadratic formula. So you're going to go into your formula sheet and you're going to find where it says quadratic formula. All right, quadratic formula right here. And you're going to type it in as you see it. Okay. So I'm going to type this into my calculator. So I have minus b, and because I have this fraction, I'm going to put the fraction in first. So I'll put divide. On the top, minus, instead of the letters, I'm going to put parentheses. I cannot put plus and minus, so I'll start off with plus, and then I'll put minus after. So now square root, so square root, and then I have b squared, so b squared minus, and again, anytime you see the letters, go ahead and put parentheses in their place, minus 4, and then I see a letter again, so a, and then c in parentheses, all over 2, and then parentheses. All right, so again, I'm just typing this. I'm just typing this here with the letters as parentheses. Because once I do that, I know what A, B, and C is. This is A. So everywhere I see A, I'm just going to copy that. Where do I see A? Here. Paste A. Paste A. All right, where do I see B? So I'm going to take B. Make sure you also take the symbol. So copy. And wherever I see B, which is here, is B. And also B is here. And then finally, wherever I see C, make sure you take the symbol with you. So the only place I see, the only place I see C, let me make this bigger, is right here. All right, boom. And notice, right, if I have plus, so let me go check my answers to make sure I did this correct. One of the answers should be 1.881, which is true. And then if I have minus, so if I change this to a minus, the other answer is 0.31, which is also true. But you see, this is not a repeating decimal. So this is the problem that we're running into. So you have to simplify all of this. But again, you can do it inside the calculator. We're going to take everything that is under this square root, everything right here. And we're going to paste it right here. In fact, I just need to make this bigger. 61. Remember, everything I took underneath here, all of this is this right here, right? So I can replace all of this, everything under here, with 61. Now keep an eye on this number. Should not change. 0.031, etc. So I'm going to take everything underneath and put that there. 0.031, etc. So I'm still good. All right. Now I'm going to take this. Let's make this into one thing. A negative times a negative is what? Positive. Again, keep an eye on this right here. It should be positive 11. Do I change? No, I'm still okay. All right. Let's take everything underneath. So we're doing it step by step, not the parentheses, the radical, the thing at the beginning, and then everything underneath. The underneath, 2 times 5, 10. So I'm going to replace this with 10. Again, keep an eye on this number. Should not change. Did not change. So I'm still good. I got one more step to do because I have to simplify. The question says in simplest form, I'm pretty sure somewhere. Yep, in simplest form. So we have to simplify this radical. All right, so we have to do books. So 61. All right, we're going to break down 61. 61 divided by 2 doesn't work. Divided by 3 doesn't work. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, and by 14, 15, 16. By 14, 16, 17, you should have found the number if you can simplify it. So 61 does not break down into anything. The last thing I need to check is, can I simplify top and bottom? So this, can I do 11 over 10 and it simplifies, as well as 1 over 10 and it simplifies? Let me check. 11 over 10. All right. It still stays 11 over 10. So because the first one doesn't simplify, the second one does not, which means that this is my answer, plus and minus. So I'm going to copy, paste it, and then change this to plus and minus. All right, I'm going to do a different one that does simplify. So let me actually kind of cheat and find one that simplifies. Let's go ahead and copy the question down, change all the B's into X's. All right, so again, remember, as long as it stays this way, I'm good. So I'm going to take this right here, take this to the other side. It's going to change from positive to what? To negative, right? So on this side, it's going to be negative. And now I have nothing there, which is 0. So notice, and why is this in red? Let's let's not do red. I'm just going to take my answer and put it back here. It just needs to be a different color. Notice blue and red are the same exact thing. So I know I've done this correctly. So this whole time, you're going to just keep doing it and checking to make sure you're right. Okay, so I'm right. Now, this is my answer. It's not a repeat in decimal. So, oh my gosh, I actually have to put it into the quadratic equation. So put it into the quadratic equation just by copying the quadratic equation exactly how it looks, but in place of the letters, you're going to put in parentheses. So there's a fraction, so start off with division. Then on the top, negative, parentheses, because that's a letter, plus square root, so radical. Inside the radical, make sure everything's inside the radical. You have b squared. Come back out, 4, or minus 4, and then a, c, and then on the bottom, 2a. So everything in parentheses, okay, everything in parentheses so that you're matching everything up. Now you're just going to go get A, B, and C. But before I got too many numbers here. So let's go ahead and take this. And again, I'm just going to double check. I'm going to put this on the line below. I'm going to double check that my question does not change. So combining 23 minus 6. So we can combine that. That's going to give me 17. So I'm going to replace this with positive 17 and just make sure it doesn't change. Red and blue are still the same, so I'm still okay. This is my ABC. So my A's, where does my A go? A just goes here and here, so I'm going to put it there and there. All right, where does my B go? Make sure you copy the actual sign as well. So B goes here and here. And where does my C go? C goes here. All right, so boom. All right, double check that. So let's see. One of my answers is negative 2.29. Negative 2.29. Yep, there it is, right? 3 because it's rounded. All right, so I just need to simplify this. So this is now what I'm working towards to simplify. So remember, we're going to take everything underneath the radical. I guess we can even go in order. Let's do this part first. We can go in order. So this part right here, negative and a positive is going to give me what? Negative, right? So make sure, check this number out. Doesn't change. So I should have negative 12 here, and it should not change that number. Boom, I'm good. Let's take everything underneath the radical. All right, everything underneath the radical is going to be 8. So I'm going to take everything underneath this radical and change it to 8. Nothing changes. Let's take everything underneath the fraction. It's going to be 4. So again, keep an eye on this number. It's going to be 4. Nothing has changed. So far, I'm so good. It's really when you get here, now you have to break this 8 down. So how does 8 break down? So let's check. 8 divided by 2 is 4. So this is right here. 2 times 4. Okay. How does 4 break down? So let's see. Let's do 4 again. 4 divided by 2 is 2. So this is 2 times 2. So this is my breakdown. Notice my number is not changing. So you're finding out, make your card so you can make your books. How many cards make a book? 2 cards, right? So 2 cards make how many books? 1. So I'm going to take that out and put 1 book outside. Again, my number is still the same. So I'm doing this correctly. My last step is to check if I can simplify these 2 right here. As long as both of them simplify with this 4, I'm good. So is there a number that goes into 1, 2, and 3? These 3 numbers right here. Yes, 2 does. 2 goes into how many times into 12? Into 6. Again, the number is going to change because I have to finish all of it. 2 goes into 2 how many times? 1. 2 goes into 4 how many times? 2. And look at that. My number is back. So this is my final answer, and this is going to be an invisible 1. So I'm going to copy that, and then I'm going to paste it with a plus and minus. So change that to a plus and minus because that's what the original question had. So that's how you simplify. All right, we're going to take a look at quadratic problems, profit and gravity. There are a few questions that you could get. It really doesn't matter. The big thing, and I'm actually going to go over all of them just so that you understand. You copy it, Control C. You paste it into the calculator, Control V. It does this weird funky thing. Just correct it. So here should be Shift 6 squared. And then I'm going to copy this, Control X, paste it, Control V. All right, so now I have it copied. Make sure, again, it's copied exactly. So negative 16x squared, 157x, and then 105. One is copied exactly, you're good. Now there are, looks like 1, 2, 3, 4, 5 different questions that you can get. So it's about reading the question, okay? So I'll actually answer this question, then answer the other 4. So let's read it. A rocket is launched. So that means it's going to go up and then it's going to go down. So if I zoom out, And this is zooming in, this is zooming out. So I'm going to zoom out till I see it. So boom, zoom out. So it's launched, so it's going to go up and then it's going to come down. Okay, so that's already ready to go. The height of the rocket, y. So they're telling you y is what? Height. So if they ask you for height, you look at the y-axis. Is related to the time after the launch, x in seconds. If they ask you for time, you're looking at what? X. By the given equation. Using this equation, find out the time. So if they're asking me for time, find time, and what's time? X. So that means they're asking you for the x value where the rocket will reach the maximum. So you have to know what maximum is. What is the maximum? Maximum is the very top of your graph, right? I'm going to zoom out. Looks a little weird, but that's okay. Click on it. There is my maximum. Now, which one of these is my maximum? So remember, you have to read the question, right? What was the question asking you? It said that time for it to get to the max. So time is which value? X. I have two possible values right now. So what is the time? The x value, 4.906. Now, if there's any rounding, this is where we have to round. So 4.906. All right, and it says round to the nearest hundredth of a second. What does that mean? There are two zeros. That means this right here is my cutoff point right here. I cut that off. I should only have two numbers after the decimal. What does this 6 do? 5 and above, add one more. 4 below, let it rest. So this is 5 and above, so add one more. So the 6 adds one more. Boom, done. All right, so what did I do? This was the time for height. Let me actually just go in order and just do a whole bunch. All right, so let me find the profit. So again, Control C. And all of this one is just reading, Control V. X out of all the extra things. These were a lot. It's fine, just X, 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 X. All right, so this is squared. Something X out of that one. And then Control X, Control V. Make sure that it's pasted exactly. It is. Now, again, let's read. Using this equation, find out the price. So I need price. I need to know is price X or is price Y. So the amount of profit Y, okay? So profit is Y. And the price is X. So whatever I do, I put in the X value. All right, so let me see the question. What is the price the widget should be sold for to the nearest cent for the company to make the maximum? Again, where does the maximum happen? At the very top. And again, what did I want? The price, right? Which was my X, because it told me my question, X. So it's 26.75. Real simple. All you have to do is just read it and understand what it's asking to match it. All right, now, round to the nearest cent. What does that mean? So if the nearest cent means I should have cents, which will be two numbers after the decimal. All right, do I have two numbers after the decimal? Yes, I do. I don't have three, so I don't cut anything off. So I am done. Again, I'm going to go through like every single question that you could possibly get so we could make sure that we understand. So copy, Control C. Control V is paste, get rid of all the extra stuff. That one was a lot. Boom. This is squared. And then I'm going to Control X and Control V. So make sure it's copied and it looks exactly the same. All right, and again, now I'm just going to read the question out that I know what the process is. Using the equation, find the maximum amount of profit. So I'm talking about the maximum. So I'm going to zoom out, zoom in. Here's my maximum. Okay, there are two numbers that could be my answer. Which one do I want? I want the one that says profit. So let's read the question, find out what profit is. Profit is Y. Price is X. So profit is the Y value. So this is the Y value that I'm going to type into my answer. 7337.862. All right, this is my profit. Round to the nearest dollar. What does that mean? They want no change, right? No 25 cents, no 2 cents, no 98 cents, nothing. No change, which means there should be no numbers after this decimal. All that needs to disappear. So before I disappear it, I look at the number after the decimal. 5 and above, add one more. 4 below, let it rest. So 8 is going to add one more. So it's going to add one more to make this 7 into an 8. Right, so I'm just going to keep doing them because all it is just reading the question, okay? Again, Control C, cross out these, Control V. It's going to give you a whole bunch of gibberish, X out of everything. All right, change the question. So this would be squared, Shift 6, Control X, Control V. Make sure the question is exactly, yep, it is. I'm good. All right, find it. So I'm gonna press home to kind of find it and kind of zoom out. There we go, and kind of go to the top. You zoom out, and I'm dragging the mouse and going down, dragging it, going down. Zoom out, zoom out, zoom out. Dragging, 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 dragging. There's the top. In case I even need the top. By the way, I might not need the top. Let's see. All right, using this equation, find the time. So time, I need to find what time is. Height is y and time is x. So find x. So whatever I get, find x. It takes the rocket to hit the ground. Okay, so let's think about this logically. The rocket goes, okay, whatever. Zoom out, zoom out, zoom out. This is not a good example, but okay. The rocket's gonna go up, right? But it's gonna run out of gas and start doing what? Coming down. So they're asking, what time does it hit the ground? So let's talk about that. When does it hit the ground? Right here. It hits the ground when it hits the ground, right? So the x-axis is the ground. And what's the time that it hits the ground? So remember, let me go find what time is. What's time? X. So when it hits the ground right here, what's my x value? So you just type it in, 15.514. And then round to what? 100. 100 means 2 zeros, so 2 numbers after the decimal. So I need to get rid of that number. Before I get rid of it, I have to add 5 and above, add 1 more. 4 or below, leave it alone. So 4 and below, leave it alone. So we just delete that. We leave it alone. So press submit. All right. Let's do another one. All right, again, Control C. And I'm just doing the 5 different problems because they can ask you 5 different questions. I'm just reading the question to you to make sure that you understand it. But the process is all the same thing. All right, so again, make the equation look the same. Shift 2, Control X, Control V. Make sure you copied it correctly. I did. All right, let's go look at the question. Find the time. So I need to know what time is. Time is what? X. So I'm only looking at X. Where the rocket reaches where? Maximum. So that means I need the maximum. So you got the maximum of the graph. You have 2 numbers there, right? You have 2 numbers there. You have the maximum right here. And I need that x value because I need time. So I'm going to say x value because of time. It gets to the maximum point. So maximum point by definition is the top of the graph. All right, so once I have that, I put that in. So that's going to be 5.3, I guess I should put it over here, 344. Round to the nearest hundredth, so 2 numbers after the decimal. That means I don't need this number. Before I get rid of it, I ask 5 and above, add 1 more, 4 below, leave it alone. So I'm leaving it alone because it's 4, so I just delete it. And that's how I answer it. I'm on the last question, I believe. All right, so here's the last type of question because remember, the question is going to change, right? All right, so I do Control C and Control V. Get rid of all this extra stuff. All right, so this needs to be squared. Shift 6, Control X, Control V. All right, and again, now read the question. Find the maximum height. I need max, so this is my max. But there are 2 answers. I could get X or Y. What is height? So let's go find it. Height of the rocket is Y. So I'm looking for the Y value right here. All right, so the Y value is this. So I'm going to write it down just like I see it, 268.063. Okay, and this is to the nearest 10th, 10. So the number 10 has 1 0, so that means I don't need anything past 1 number after the decimal. So this needs to go away. Before I take it away, let's look at the 6. It's going to change this 0. So 5 and above, add 1 more. So because this is a 6, it is 5 and above, so I add 1 more. Quadratic word problems. And this is going to be dealing with area only, so I'm only going to do the question that talks about area. So here's a question that I'm talking about. The best thing for you to do is identify what your keywords are. Okay, so let's take a look at it. The width of a rectangle is 2 units less than. Okay, less than. All right, means smaller. So 2 units less than the length. All right, now the only thing about this less than you need to remember is this example. Miss Ainley goes to the cafeteria from her classroom. Okay, so I'm going to say it again. Miss Ainley goes to the cafeteria from the classroom. Where did I start? So even though I keep saying cafeteria first, where did I start? Miss Ainley goes to the cafeteria from her classroom. Where does she start? Her classroom. So even though classroom is second, she still starts at the classroom. So listen to this. The width of a rectangle, so W, right, is 2 units less than the length. So it's telling you, you're going to start with length and then you're going to subtract 2 because it's 2 units less. It's 2 units less than the length. Okay. So 2 units less than the length. So let's draw this picture. So you're going to have a rectangle. All right. So you have the width of the rectangle is this part. And then you have the length is this part. And then it says that the width of the rectangle. So this is the width, the W, right? So I'm actually going to delete the W real quick. And then it says that the width of the rectangle is 2 units less than the length. It's less than the length. So I'm going to take the length and subtract 2 because it's less than the length. And that makes sense because the width is shorter than the length in a rectangle. The area of the rectangle is 15 square units. So when I multiply length or width times length, I'm going to get 15 units, square units. What is the length in units of the rectangle? So they're asking you, what is L? So let's define the problem. So we've got the length, okay, and then we've got the width is 2 less than the length. Okay, so these are the problems. So I've got length is L and obviously width is W. Okay, so I've defined my problems. I kind of did it here before I did it. All right, so what is the length in units for the rectangle? Solve by factoring or decimals. So what am I doing? In order to find the area, we know it's length times what? The width. The area of a rectangle, any rectangle, is the length times the width. No, the width times the length, it doesn't matter. So the area for this rectangle is going to be my length, which is what? L, because I don't know what it is, times, and I'm just going to put it in parentheses, my width, which is what? What's my width for this one? L minus 2. And when I multiply these two together, I'm going to get what number? 15, because that's what they tell me. The area is 15. So we're going to let the calculator do this for us. Only in place of L, I'm going to use X so that it can give me an answer. Because if I put in L, so let's put in L. L minus 2 equals 15. You can see I don't get anything. Why? Because I'm putting L. We're going to use variables that the calculator recognizes. Boom. I put in that. I know there's a graph already. I clicked home. I can already see it. So how do I find my two solutions? They're right here, right? So L is -3 and L is 5. So I'm going to come right here and go L could either be -3 or +5. Now let's think about this. Could the length of a rectangle be -3? No. So that answer doesn't make sense. So sometimes you get an answer and it doesn't make sense. So this doesn't make sense. So the length has to be what? 5. So if the length is 5, so my length of my rectangle, this length is 5. What does this have to be so that it's equal to 15 when I multiply them? Well, it has to be 3. Let's double check that. Remember, we said that it's L minus 2, right? So L minus 2, all right, is going to be 5 minus 2, which is going to be what? 3. So my width does work out for it to be 3. Now I can go and answer whatever the question was, which was, what is the length? And be careful, because sometimes they ask for the length, sometimes they ask for the width. All right, so what did we find our length to be? Our length was 5, so I didn't even have to do this extra step. I'm just going to go put it in as 5. Now, I'm going to do a couple of these problems because, you know, this is the first time that you're seeing it, and I want to make sure I cover it. The length of a rectangle is 2 units more than the width. Okay, so again, start with the picture. It's always easier for you to see it from a picture. All right, so length is the longest side, and they're saying that that length is 2 units more than the width. So it's whatever the width is, which is W, plus 2 more. That's the length. And the width is just the width. So this is the equation that I have. So when I put this in the calculator, oh, and that's going to give me what? When I multiply them, it's going to be 48. So my area is length times width. When I multiply them together, I'm going to get 48. And that's what we're starting with in the calculator. So when I put this in the calculator, I'm just going to use the length, which is W plus 2, but we're going to use X because I need to know it to appear. The length times the width, so that's times X, because we're using X in place of W. I get my answer. These are my two solutions. Does it make sense for my width to be -2, because those are my X's as W's? No, it doesn't. So my width must be 0. Oh, wait, I made a mistake. Something's wrong. Because I didn't tell the calculator what this is equal to. When I multiplied length times width, it has to be equal to what? 48. And that's what's wrong, because I can't have a width of 0 and a width of negative. That doesn't make any sense. So I'm going to have to say, hey, calculate -48. So that's going to be, you know, a hint for you if you get in things that are not possible that something's wrong. All right, so now I have a width of -8, which is not possible because I can't have -8 distance, but I can have 6. So I have a width of the one that makes sense. My width is 6. So if my width is 6, so if this is equal to 6, here I will have 6 plus 2, which is equal to 8. And is that true? Is 6 times 8 48? Yes, it is. So that works out. So my length is going to be 8. My width is going to be 6. And depending on what the question is asking, that's what you're going to put in. So it's asking for length. What did I have my length as 8. And so you're going to put in 8. So just be very careful to read the question to see which one they're asking you for. Are they asking for length? Are they asking for width? When you find your answer because you used X, make sure you look at your picture because you drew a picture, right? Make sure you look at your picture and see the X represents which one, either the width or the length. All right, so make sure you're looking back, okay? Because you see in this question, it represented the length, but in this question, it represented the width. Let's practice. So now we're going to look at quadratic word problems area with a different method. This is called London's method. London is a student that I had in 2004, and she was having a problem with the variables. So basically when we say the length of the rectangle is 1 more than the width, so W plus 1. And then you have to multiply that times the width, and that's going to give me the area of 72. So she was having a hard time, and of course with this you have to change them into X, sorry. She was having a hard time doing these questions like this to where she could see, okay, well, it's got to be 8 because it cannot be, sides cannot be -9. So what she came up with is what I'm going to show you now. She understood that to find the area, you're taking length times width, meaning you're multiplying two numbers to give you this area. So if the area is 72, she says two numbers made this area. So what I can do is I can find all the factors of 72. So for example, 2 times 36, that's going to give me 72. But I can't assume that this is the answer because there's one more stipulation. Not only when you multiply the numbers do they have to be 72, but there has to be 1 unit more than the width. So one number has to be 1 unit more than the other. So when you look at 2 and 36, is 2 or 36 1 unit more than the other number? No. Because if I take 36 and subtract 2, it's 34. And so she said, what you keep doing is finding different factors of 72 until you see the difference of 1. So 3 and 24, are these numbers different from one another with just 1? No, they're not. So we're going to go to 4. 4 and 18 is a factor of 72. Are they different by 1? No, they are not. So we're going to go to 5. 5 and 14.4, they're different by 1? They are not. So I'm going to go to 6. 6 and 12, are they different by 1? They are not. So I'm going to go to 7. 7 and 10.2857, are they a difference of 1? They are not. So I'm going to go to 8. 8 and 9, are they a difference of 1? So I'm going to check that, right? So 9 minus 8. 9 minus 8, is there a difference of 1? Yes. So what London was saying is that if I take 9 times 8, I'm going to get 72. So my length and my width must be 9 times 8. And the reason I know that this works is because their difference is 1. Now I have to finally decide which number is length and which number is width. Well, just think about a rectangle for a second, right? In fact, I'm going to make, this is a rectangle, right? This keypad right here is a rectangle, correct? So if you look at this rectangle, there's always going to be a longer side and a shorter side. Which side is always longer? The length. The length is always longer, L for long, and then the width is short. So if you look at this, if I'm looking for the length, am I looking for the long number or the short number? All right, so you're looking for the long number. So out of these two numbers, which one is long? 9. And if I was looking for width, then I'd be looking for the short one, which would be 8. Okay, so that is London's method. So now we're going to do London's method just a little bit faster. Why isn't it submitting? I don't know why it's not submitting, but I'll just go to another question. It's not a problem. All right. All right. So this time, the area of the rectangle is 15. So the number that we are starting with is 15. And we're looking for factors of 15. So I'm going to start with 2. 2 and 7.5, are they 2 units? So the length minus 2 is the width. Are they 2 units apart? No, they are not. So that's not it. So I'm going to go to 3. 3 and 5, are those 2 units apart? Yes, it is. So what it's saying is if I take 3 times 5, I'm going to get an area of 15, and 5 minus 3 is going to give me 2, which means one of the numbers is L minus 2. Okay. Now that I know this, when I look at my factors, which one is longer, which one is short? What is the length? So this one is asking for the long one. Out of these two numbers, which one is short, which one is long? 5. So this is going to be your length is 5. All right, so I'll do a couple more. Let me not do one where it's the difference of 1. Here's 6. Okay, so let's do 6. The area is 7. So again, you start with 7. All right, 2 and 3.5, is it 6 difference? The width of the rectangle is 6 less. Is it 6 different? No, it's not. So you go on to the next number. 3 and 2.3, is it 6 different? It is not. 4 and 1.75, is it 6 different? No, it's not. 5 and 1.4, is it 6 different? No, it's more than, because look at this. 5 minus 1.4 is 3.6, so no. All right, 6, is it 6 different? 6 and 1.166666? Nope, because even if I do 6 minus 1.66, you can already see it's 4 point blah blah blah, right? All right, so I'm on my last number, 7. 7 and 1, is it 6 different? Yes. All right, so what we're saying, 1 times 7 is 7, which gives me the area, and then 7 minus minus 1 is 6 different. So these are the two numbers that I'm looking at. And now what do I look for? I'm looking for the width, which means out of these two numbers, I'm looking for the shorter number. The shorter number is 1. All right, let's do one where the area is bigger. 35, 12, 32, 20, 30, 32, 54, 24. Okay, I guess it doesn't get too big, so I'll just do the next. So I'll do 30. All right, so I'll do one more. So my area is 30. Let me find my two numbers, and they are 1 apart. Okay, so that's not 1 apart. Moving on. That's not 1 apart. That's not 1 apart. 5 and 6 is 1 apart. So 5 times 6 is what's going to work. Okay, and I'm looking for the length. So what am I looking for? The small or the long? The long. So the longer number is 6. So that is London's method. All right, so we're going to take a look at consecutive integer problems. There are 1,000 of these that they could give you. One of them is product of consecutive integers. And what does product mean again? When I multiply, right? So this is saying when I multiply two consecutive integers. So let's talk about a couple of things. Consecutive means next to each other. Like, for example, 8 and 9 are consecutive numbers, right? So they're right next to each other. All right, so, and then product means multiplication. Okay, so this is asking what two numbers am I going to, that are right next to each other, am I going to multiply so that, oh, and they have to be negative as well. So negative, so now I gotta switch the sides. I apologize for not reading. So negative 9 times negative 8, those are consecutive negative integers. So you do have to read what the question is saying. Sometimes they're talking about positive, sometimes they're talking about negative. And they're wanting to know what two numbers multiplied together that are negative, that are right next to each other, are going to equal to 30. And we've talked about finding the factors of 30. So 2 and 15, they're not right next to each other. Let's try 3. 3 and 10 are not right next to each other. 4 doesn't work because it gets 7.5. 5 and 6, these are numbers right next to each other. Now the question is, can I make them negative? Can I make them both negative because they say negative integers for them to give me 30? So we're going to look at that. So if I had negative 6 times negative 5, would that give me positive 30? And this is the question that we're asking. So let's take a look at it. So we got negative 6 times negative 5, and yes, that gives me 30. So these are my consecutive negative integers. So that's the London's method that we came up with. But now we're going to take a look at just doing it in variables, because the reason being, you could get an answer choice that isn't two numbers, but rather it's in variables. So we're going to also talk about how do we do this in variables. So let's go ahead and do that. So we have two consecutive integers. So we have let's call the first number x. So let's say if x was 2, the next one would be 3, right? So then the next one, and I have to multiply them together. The next one, if the first one is x, has got to be x plus 1 because it's right next to x. It's 1 more than x. And when I multiply these two together, I have to get 30. Okay, so that's the problem setup. So I'm going to say it one more time again. You start off with an unknown negative integer. So I don't know what it is. I just know it's negative. So I'm going to call it x. Then to get the next value, so if I had, so for example, if I had -6, which I know is the answer, the next one up would be -5. The next one up would be -4. The next one up would be -3, and so forth, right? So to find this next one, we know just we're adding 1 to this last one. So if this one was x, we're just going to add 1 to it. It'll give us the next number. And then we have a problem that we can go ahead and solve by factor, which again, we can do right up in the calculator, or you can do by hand, whatever your process is. For speed purposes, I'm just going to do it in the calculator for today, but you are definitely welcome to do it by hand. So there so where are my solutions? I'm going to come, let me go home so I can get there. Here are my solutions, -6 or +5. Now, we do have to read the question because it has two solutions, right? But it says 2 consecutive negative integers. So which one is negative? So it's -6. So here we know x is -6. So if the first one's -6, -6 plus 1 will give me -5. So it's -6 and -5. So you get to the same place, but now you know how to set up the problem, because sometimes they won't give you the actual answer. So maybe they say the product of these 2 consecutive integers is some other variable, let's call it y. And you have to know how to set this up equals y. And that's the reason you do have to know how to mathematically set it up. But if you do want to use London's method, I am all for it. Let's take a look at another one. So this was, I think you add, so and then read the question. Find the value of the lesser integer. So -6 comes first. So it's -6. All right, we'll take a look at transformations, okay? And the only ones we're going to look at are the ones we're dealing with in Algebra 1, which is quadratic and square root. We actually do absolute value, so I'm going to put absolute value as well. So everything but generic, okay? Because it doesn't matter what it is as long as you know the rules. If you don't know the rules, go and watch that video where I go over the IXL, because I don't have the time to explain all of it. We're just going to do it via the calculator. All right, so really, to do this via the calculator, you need the original question. All right, so this is the original question. Let's see, copy. Let's see if it'll paste it. Yeah, it pasted, so we're just going to X out of the rest. All right, cool. Let me make sure the graph is here. Home. I don't see the graph. So it must not like something here. So there's an error. Okay, they don't understand the L symbol, so we're going to have to manually put it in. So come right here. Find absolute value right here, and it's X. All right, now it's there. So you're going to have to manually put that one in because it doesn't like the copy and paste. Boom. So this is the original one. We need it to come right here. Okay, but these are our options. So what we're going to do is we're going to take our options and see which one is going to give us our answer. So let's start with this first one. And again, it's not going to like the copy and paste, so I'm just going to do it manually. So I'm going to paste this here, and it's supposed to have a negative outside and a -1 in there. All right, so does this graph right here look like this one? No. So let's try this one. This is a negative outside and the -1 is inside. And you're just putting in the answer choices C. So does this graph look like this? No, because it looks like it went to the other side, right? So let's try this one. -x plus 1. I'm going to try this one actually so I don't have to erase. +1. Okay, this might look like it is. Is it it? So let's take another look at a point. So we've got -1, 0. -1, 0, and then we got 0, -1, 0, -1. This is it. This is the answer. So this one is the answer. So you're just going to put in all the answer choices and see which graph matches up. To me, it's faster just to do it by hand, but again, it really doesn't matter. So you're just going to put it in and see which one matches up. So we're going to start off with the original equation. I really don't even need to do that. I can just put in the answer choices, right? So we're going to X out of these, square root. I'm just putting in the answer choices and sees which one gives me the dotted line. So we've got x plus 4, and then you come outside. Make sure you come outside, plus 3. And does it look like this? So this point is at -4, 3. Is this -4, 3? Yes, it is. And is the y-axis, does it cross the y-intercept at 5? Yes, it is. So it just so happens the very first one I tried is the answer. And so you're just going to hit submit. All right. So you're just matching it up because now you're using a calculator. Um, doesn't matter what the question is. I'm going to show you one more. We did absolute value already. All right. Here's another question. So I need to make it look like this. So I'm going to type this in. And I think it will let me copy and paste this. Let's see. All right. So it's squared plus 2. All right, so again, once you copied and pasted in one of the answers, okay, does it look like this? It kind of looks like it's on the right. Is it at 1, 2? Let's see if it's at 1, 2. 1, 2, yeah. Does it cross at 3? Let's see, does it cross at 3? It does. So the first one I put in happens to be the answer. So you're just going to keep putting in your answer choices and see which one matches up. And that's all you have to do for that. All right, so transform functions. Okay, so remember, before you can apply the rules, you must know the rules. All right, so you do need to pull up your notebook once again. So on transformations, and really what you care about is this two boxes right here. Oops, I didn't hope to do that. So these two boxes is all that you need to look at. So you need to ask yourself the first question, is it inside, outside, or is it a negative? Okay, is it inside, outside, or is it a negative? So let's see if I can kind of have both of this up there. Move this over here. Okay. All right, is it inside, outside, or is it a negative? So I'm looking here. So my function is related to the x. So right now I have something outside and I also have something inside. So let's deal with this 3 first, okay? This is outside. So I answer, oh, it's outside. All right, so outside is y and regular. Outside is y and regular. So it's the y-axis. It's got to do with something going up and down. And it's whatever you think. All right, so keep this in mind. Now you ask yourself the second question, okay? Is whatever is outside, are you adding or subtracting it? No. Am I multiplying it? Yes. So if I'm multiplying it, it is either a stretch if it's a whole number or a shrink if it's a fraction in the x or the y direction, because I already know it's outside, it's y. So this is a stretch because it's a whole number in the y direction. And it is exactly what I think because it's y and regular. So it's going to stretch in the y direction by 3. So I'm going to look at any point I want. This one, this one, this one, doesn't matter. And I'm going to stretch it by 3. So multiply 1 by 3. This point, I stretch it from 1 to 3. Or I can stretch this one. This one's at 2. 2 times 3 is 6. I can stretch this one to 6. You see how it's still the 3 and now the 6? Doesn't matter which one you pick. This one is at 3. So stretching that times 3 will take me to 9. And again, that's the exact same points. 1 times 3 was 3. 2 times 3 was 6. And 3 times 3 is 9. So it doesn't matter which point you pick as long as you're stretching it in the y direction by 3. All right, so that's this point right here. Now I'm going to look at the inside. In the inside, what do I have? I have minus 5. So again, I go back to my notes and I ask one of these questions, okay? Is it inside, outside, or is it a negative? It's inside, right? So inside is x and opposite. So you need to keep that in mind. All right, then I go to the second question. Am I adding or subtracting? I am. I'm subtracting it, right? Subtracting is a shift. So you're moving, okay? You're shifting. All right, and then keep in mind the x direction is either going to be, look at the x-axis, you're either going to go right or you're going to go left. And it's going to be opposite of what you think. Okay, so looking at this negative 5, I would think to go to negative 5 is left, but it's going to be opposite of what I think, so move to the right. So you're going to move to the right 5, and that's all you have to do. So once you know the transformation rules, you just need to apply them to a graph. Then you submit your answer. So I am going to do a few more of these just to make sure we're fine. Doesn't matter what graph they give you. So find your x, that's the function. Look at everything else. So I have two things. I have this negative outside and I have this 1/3 outside as well. All right, so I'm going to start with this negative. I'm going to ask these questions. Is it inside, outside, or is it a negative? It's a negative. All right, negative is opposite no matter what. So keep that in mind. Then you go to this. Is it adding and subtracting? Nope. Are you multiplying? Nope. It's a negative. Negatives are flips over the x and the y axis. And we just said it's opposite no matter what. So it's flipping opposite of what you think. Okay, so let's go to this. It's outside. I would think it's y and regular, but it's going to be opposite. So instead of it flipping over the y-axis like I would think, it's going to flip over the x-axis. If you're having problems with any of these transformation rules, go and do the transformation rules first and then come and apply it. So I'm going to flip it over the x. That means take any point and move it completely in the opposite direction over the x. So this is 1, so it goes to 1 right there. And again, you can take any point. This one is 1, 2, so I'm going to go 1, 2. You can take any point at all. 3 is going to go down to 3. Okay, so it does not matter what point, you're just flipping it over the x-axis. So that's done. Now I'm going to look at this fraction of a third. So again, I come back to my notes. Inside, outside, or negative? Well, we're just dealing with outside. It's y and what you think. Okay, whatever you think it is, it's in the y direction. All right, are you adding, subtracting it? No. Multiplying? Yes. All right, stretching is a whole number. Shrinking is a fraction. So what is it? A fraction. So I think I'm supposed to shrink it. And again, outside is y and what I think. So it is shrinking. So I'm shrinking it by a third. Now multiplying a number by a fraction by 1/3 is the same as just dividing by 3. So on this equation, I'm just going to divide by 3. So I'm going to shrink each point by 3. So I'm just dividing by 3. Now, if I take -4 and divide it by 3, it's not going to give me a nice number. But if I take -3 and divide by 3, it's going to give me -1. So this -3 is going to shrink in the y direction to -1. All right, I'm going to get the next one wrong just so I can get more questions because I know we need them. All right, as a matter of fact, I'm going to do ones that we haven't done. So we did absolute value as the, in fact, let's do this one. All right, cool. All right, so again, find the x, that's your function. All right, I have a third outside. We just talked about this on the last question. All right, a third outside. Outside is y and regular. A third is multiplication. Shrink is a fraction. Stretch is a whole number. So shrink, y, and what I think. Okay, regular. So I'm going to take something that's divisible by 3, like the number 3. 3 divided by 3 is going to give me 1. So I'm going to shrink it in the y direction. Then what does a +4 outside do? All right, so let's see. Outside is y and regular. Plus and minus is a shift, right? So because I'm shifting in the y direction, I'm either going to go up or I'm going to do it down. And it's because whatever it is that I'm thinking, right? So +4 in the y-axis, +4 is over here. And it's supposed to be what I'm thinking. So this is going to shift up by 4. Again, if you're having problems with the function rules, you need to go do the work for the function rules before you apply it. And that's all you're doing. All right, let me do just maybe a couple more. Again, doesn't matter what it is. Find your x. So here's my x. All right, -5 inside. Okay, so inside, x and opposite. I'm going to get a little faster now because we've done it over and over. X and opposite, and then adding and subtracting is a shift. Okay, x direction. So it's this way or this way, right or left. And opposite of what you think. -5, I would think go this way, but I'm really going to go this way. So I'm going to shift it 5 to the right. +3 outside. Okay, adding and subtracting is still a shift. So outside is y and regular. So whatever I think. So I think in the y direction, +3 is going to take it up 3. And that's all you're doing. All right, I'm going to get a couple more wrong just so I can just do a few more. All right, doesn't matter what the function is. So find your x. Here's my function right here. The only thing that's happening to this is there's a 4 outside. What does a 4 outside do? So outside is y and regular. Is it adding and subtracting? No, it's multiplication. Whole numbers are stretches. Okay, so this I would think is stretching, and because it's outside, it's y and what I think. So stretch by 4 in the y direction. So take any number and multiply it by 4. So 1 times 4 or 2 times 4, doesn't matter. 1 times 4 is 4, stretching it in the y direction. All right, I think we just did this one, but anyway, inside, x and opposite. So instead of going left 2, I'm going to go right 2. Outside, y and regular. So instead of going y and regular, so whatever I think is in the y direction. So that's going to be down 3. Looks like I'm on my last question. A half on the outside is y and regular. A half is a shrink, and what I think it's going to do is it's going to do that. So it's going to shrink it by a half. So multiply these numbers by a half or divide by 2. Doesn't matter. So 4 divided by 2 will give me 2. All right, so this is going to be Transformations of Functions AI calculator version, like if you don't know the rules. So what you're going to do is type in the question. So y is square root of x. All right, once you have the question, you're then going to put in your answer choice. So you see that that looks like that one, right? Now you're going to put in the answer choices to see your transformations. So you're going to say y equals the first one, which is negative x plus 2. Does it look like that? Okay, so now we're going to zoom in to make sure. So you see this starts at 2, that starts at 2. And let's see if I can just find one corner just to make sure right here. So 7, negative 3. So let me make sure that 7, negative 3 is on the perfect, and it is. Okay, so now I've correctly matched it to answer choice A. All right, so that's how you use the calculator. All right, so right translated function. So again, if you know your translation rules, this makes it very, very simple. You do have to know what the parent graph is. So what is this one? Is cubed, or they tell you in the question that's even perfect. It's cubed. You could get a whole bunch of them. What's this one? Quadratic, and again, it tells you in the question. What's this one? It's a V, right? Here's a V, that's absolute function. So you could get a whole bunch. The important thing is to know what it is, okay? So let's read what the question is saying. The graph f of x is negative, again, because I can see it flipped, so that makes sense. Write the equation of the function, which would take it up 3 units. Oh, okay, so all this means is you start with the original function, and what does it mean to take it up 3? It needs to be outside, right? Outside, and it's y and regular, so it should be negative x plus 3. I'm not going to type this in for time so I can show you like a whole bunch, but I am going to show you solution. So here it is, whatever it is, and then plus 3. Oh wait, did I not read this shift up? What did I read? Left. Okay, clearly I misread that. Okay, so if it was up, it would be plus 3 on the outside, but it's left. All right, which means you're inside, which is opposite of whatever you think. You think left is minus, so it'll be plus. See that? All right, I'm going to do a whole bunch of these, so I'm not actually going to put the question in. We're just going to do them, okay? All right, so let me show a question. What are we doing? We're moving left, and I'm going to read it. Left 1 unit. That means this is my parent form. My parent one is this right here. So inside the parentheses, I'm put one right here where the blue is. I'm going to move it left. So left is minus, but it's opposite of what I think because it's inside. So it's going to be plus 1. So show a solution. So 2x plus 1 inside. Okay. And again, I'm just going to do, in fact, let me do one of everything. Here's a cubic one. Identify what the parent, okay, these are too many lefts. Let me find something else. Okay, let's do a right one. All right, so here's a cubic function. So identify what the parent is, cubed. So the parenthesis is going to be right here where the blue is. And now we're moving right 4 units. Right is inside the parenthesis, x and opposite. So you think right is plus, so it's really minus. So inside the parenthesis here should be minus 4. Everything else staying the same. And the way you would do this in Desmos is you would put the answer choice. So you'd put the question and the answer and just see, did it move to the right like they're showing you for spaces. All right, let me do another one, square root. All right, so square root, we just did a right one. Let's do something else. All right, down. This is outside, right? Out y and regular. So this should be outside your parent graph. And what is your parent graph, right? This is an exponential function. So you know that x is raised to the power. So this right here, right, within here would be your parentheses. So I want to move it down 5 units. So that will be outside your parentheses. You want to move it down 5 units. Okay, and again, all right, see outside your parentheses, which would be right there, you're moving it 5 units. Again, all you would do is put in your question and your answer choice if it's multiple choice and see which one moves it down 5 units. All right, one more. We've done all of them. I'll just do one more just to see. Down 1, we did that one. Okay, up 2, we haven't done this one. All right, so again, here's my parent function, square root. I don't think I did this one. Here's my parent function, square root. It's not letting me highlight. So inside your square root are your parentheses. All right, and you're moving it up 2 units. So that's y and regular. So this is all the way outside. So not in here, but outside plus 2. All right, so outside plus 2. All right, so again, they're showing you how it's moving here. If you put your question and your answer, you'll see this graph, then this graph, which is obvious that this has moved up. All right, so I'm going to do the rules first, and then I'm going to do a calculator. So I'm going to do the rules with a visual of Desmos, but honestly, you do not need to do this on Desmos, but I'm going to use the visual of Desmos to teach it to you. I'm going to zoom into where it's going up by 1. I'm going to type in, so it says the quadratic function f of x is plotted on the graph. The vertex of the resultant is 5, -3. Okay, so this is 5, -3. That's the vertex. So the vertex is right there. And again, I'm going to zoom into where it's going in by 1. All right, 5, -3. So I'm starting right here. Then I'm going to take that, okay, and I'm going to have a new function after I apply these transformations. So now I just need to apply those transformations to this dot, and it'll give me my new function. So what is +3 inside going to do? Remember, it's x and opposite, so it's going to move 3 to the left. So I'm going to go 1, 2, 3. So now I'm right here. Then what is the +5 outside going to do? It's going to go up 5. So I'm going to move 3 left, 1, 2, 3, 1, 2, 3, 4, 5. So I'm going to be at 2, 2. Okay. So that is just the visual so I can count. Now I'm going to show you a different way. Again, just if you know the rules. And then after that, I'll show you a calculator. And so you have 3 options. So just keep watching this one even through the calculator to choose the one that you like the best. So again, you start off with whatever the vertex is. Actually, with this one, without actually even the calculator, my apologies. Give me a second because I need to write something. All right. All right. So again, you need to know the rules. So what is the rule here? What is this +3 going to do? It's going to go up 3, right? And what axis is up 3? The y-axis. So I'm going to come here. This is x and this is y. And the only thing I'm changing is nothing happens to x. But here I'm going to go up 3, which is +3. -4 + 0 is -4. -5 + 3, and you can put that in the calculator, is going to be -2. And that's my new point. So you can use Desmos as a visual, -4, -2. You can use Desmos as a visual, but if you don't want to, you don't even have to type it in. You can do it right here. And I'm going to do one more just like that. This time I'm not even writing it down. What does this mean? Left 3. Left is x, so this is the one that's changing by going left 3. So it's at 6 right now, so it's going to go left 3, so it's going to be at 3, and the y is not going to change. And so, again, if you're knowing the rules, you can see how fast the question is. If none of those methods have made sense to you, let me show you the calculator. All right, so calculator. You start off with a vertex being here. So we're going to talk about, well, what is vertex form? So we're going to go to quadratic. Here is vertex form. Vertex form is 1 parenthesis with numbers inside and outside and maybe a number in the beginning. So I'm going to go here and I'm going to say 1 parenthesis with a squared outside and there's always an x, right? So that means this is my beginning. But when I look at this, this beginning is 0, 0. So how do I change 0, 0 to 6, -6? Well, remember this is x and this is y. So I'm going to try something. I'm going to say, well, +6 and what do I say there? -6. All right, when I do that, I'm going to check the vertex. Okay, if you look at the vertex, it's close, but it's not quite. So the y is okay, but the x is not. And why is that? Because remember, x is opposite. I really just forgot that, you know, when I put something in parentheses or take something out of the parentheses, I need to change the sign. So it's going to be negative. So let's try that. Let's find it. All right, boom. I'm good. So I have correctly plotted my graph. So this is my function. Then what do I want to do to it? All right, so I can do one of 2 things. And actually, it just depends on what you think is easier. I can type in my function and then just type in whatever they have. So it's +4, and where is this +4? Inside, right? So I can go +4, and that's my transformation. So it's moving, and of course, if you know the rules, this means it goes left 4. So let me double check that for us. So 6, this is going up by 2, so this is 2, 4, perfect. So this one is 2, -6. Now, before I press enter, the second way you could do it, if you don't want to do it that way, you can tell the calculator, hey, this is the function f of x, and what I want you to do to this function f of x is add 4. Let's see if that does it. Okay, maybe it's g of x. Actually, I think you're supposed to type g of x is, and again, I'm learning also with the calculator. Yeah, that's what it is. So you type it in. So once you find the vertex, you call it, because it says y is f of x. You call that f of x, and then you just type in whatever it is the question is asking you, and it's going to give you that transformation. I'm going to do one more just to make sure. So again, the big thing with this is that you just find the vertex. Okay, so I don't know why that's not pressing enter, but new problem. Okay, it's frozen. Let me refresh. All right, so again, let's find one that's harder. Let's do that one. Okay. So again, we start off with vertex form, which is 1 parentheses. And we can say it's f of x. So f of x is that, right? 1 parentheses. And then now we just need to write this in vertex form. So remember, it's x and opposite. So this should be -4. And then outside is -6. All right, once you have it, confirm that it gives you the vertex or the point. Now, just to be sure that you understand, it doesn't have to say the vertex. If it says a point, you just know that this is the vertex, but you can still use it so you can track your answer. So what I'm saying is this, it doesn't have to be the vertex. Any point at all. If they say this point is moved to this point, it's okay. You think of it as the vertex so that you can do it for any question. Then I'm going to type this whole thing because now my new function is g of x. And how do I get g of x? By taking f and applying these transformations to it. So boom, that's my new point. And if you know the rules, this says it goes left 2 and up 4. So let's double check that. Left 2 and up 4. Left 2 and up 4. So now it's going up by ones. Okay, so 1, 2, 1, 2, 3, 4. Perfect. And so my new vertex is 2, -2. All right, but again, you don't have to type in f of x. So if you're not typing in f of x, what you're going to do is, again, find the vertex, confirm it's the vertex, copy it down again, and then just put the numbers without doing anything else. So I need a +2 inside the parentheses. So I'm going to come to the end of inside the parentheses, +2. Then outside, I'm going to +4. So I'm going to come up to the end and put a +4. And again, that's going to do the same thing. Really understanding what each thing tells you, or understanding definitions. Okay, so there are different questions that they can give you. So this case, it's the y-intercept. I'm kind of just going to speak about all of them. I'm just going to see what all the different problem types they can give you, so I make sure I can go over it. So I'll do it from here. All right, what is your y-intercept? Where does it cross over the y-axis? So here's the y-axis. Where does it intersect with the y-axis? At -5. All right, so when you put in your answer type, you have a choice right here. You can say, is it 2 points? No, because it's just crossing at -5, right? Is it 1 point? Yes, you could write this as a point. All right, what if I'm looking for the x-intercepts? So I'm going to look where this graph, the blue graph, crosses the x-axis. So this is going to be at 4 and at 6. And how do I write that as a coordinate? It's going to be 2 points because it crosses twice at 4, 0, because it goes x and then y, and at 6, 0. Right, so we've done y-intercepts, x-intercepts. Let's do another one. So we did x, y. Let's do coordinate at zeros. Right, so coordinates at 0. So remember, there are 4 different ways of saying the exact same thing, right? So x-intercept, solutions, zeros, and roots, right? 4 different ways. They all mean the same thing. It just means the x-intercept. So what are these x-intercepts? There are 2 places that it crosses the x-axis. So there's 2 points. They are going to be at -7. So how do I write that down? -7 for x, 0 at y, and -5 for x, and 0 for y. So again, 3 different words that mean the same thing. X-intercept, so it crosses the x-axis. Roots, solutions, and zeros. I think I said before. All right, so perfect. So same thing over and over again. All right, so we've done y intercepts, x-intercepts, zeros. Let's do vertex. So what is the vertex? The vertex is where the minimum or maximum occurs. So that point is right here, in this case, right here. So what is this in terms of x and y? It's -5 and -9. So the vertex is 1 point, all right, which is -5 and -9. So this is just knowing your definition of what a vertex is. All right, let's do another one. All right, coordinates of a vertex. Similar problem because I already had a minimum. I just want to do one that's a maximum. All right, so maximum, again, the vertex is either the top or bottom of the graph, which is here, the top. So this is going to be 1 point, and the vertex is -6, -6, and +1. So you put your x value first, -6, and then your y value 1. So -6, 1 right here. All right, and then the last thing that we're going to take a look at is your equation of axis of symmetry, and the key is in the word equation. Anytime you see an equation, there should be an equal sign. So points are not going to give you an equation. Equal sign. And when you have this, you need to put an equation. So determine the equation of the axis of symmetry. What does that mean? Where it crosses, where it splits the graph exactly in half. So symmetric means like it looks the same on both sides. So if I drew an invisible line right here at -2, it would split the graph exactly in half. They would look the same on the left and on the right. And remember, it must be an equation. So I do not put -2 because -2 doesn't mean anything. It has to be because this is a line. X equals -2 because it goes through it. So x equals -2. So again, where do I split the graph? Into exactly the same on the left and the right. I'll do one more. Let me do a maximum this time just to make sure that you understand it doesn't change. So it's just definitions. Okay, axis of symmetry is where you draw your straight line to split the graph in half, right? Which is right here. So you come right here. It's when x is equal to what? 2. And remember, it is an equation, so you must put it in as an equation. X is equal to 2. So we'll take a look at quadratic extreme from an equation. It doesn't matter what the equation is. You're going to type in the equation, and you don't have to type the f of x, but I'm just going to go ahead and do it anyway. X minus 9, x minus 5. So I've typed in the equation. Determine whether this quadratic equation has a minimum or a maximum. So let's go home. What is that? A minimum, because it has a bottom. All right, so this has a bottom, a minimum, and then you can see this is not a coordinate. It's just asking what the value is. So when you think of it this way, if you go to Six Flags or you go to a roller coaster, they have a minimum height, right? A maximum height, right? That's all it's asking for is the y1, not the coordinates. They don't care how wide you are, but they only care how high you are. So my maximum height, so x and then y would be -4. So just be careful to make sure you read the question. If it's asking for vertex, I'm going to write the coordinate. If it's asking for just what is the minimum, what is the maximum, you're just going to type in the y value. How tall are you? All right, so again, we're going to copy the question. It doesn't matter what form it is because you know it's going to show it to you. So this is now vertex form because it has 1 parentheses. The other one was factored form. Zoom out. All right, this time, right, it has a top, which is a what? A maximum. And once again, if it was asking for the vertex, I would write this coordinate as a vertex. However, it's asking for the maximum value, the tallest I can be, the highest I can be. And the highest I can be is -5. Not the widest, the highest. So that maximum value is -5. So again, just understanding the difference between what is a maximum or minimum value versus what is a vertex. All right, we'll take a look at interpret. And the only one I'm going to focus on is the meaning of the vertex because the rest of these, how long it's in the air, increase and decrease in time at the highest, greatest height, initial height, they've been done in parabola features. So if you need those ones, go to parabola features. All right, so here's my question. Natalie launches a toy rocket. So obviously it's going to go up and go down from a platform. The graph below shows the height of the rocket after t seconds. So this is the height, this is the time. So the rocket goes up and then it comes down. So notice it doesn't go any further than that because it starts when you throw the rocket or when you launch the rocket, and it stops when it hits the ground, doesn't go under the ground. All right, the x-coordinate or t-coordinate of the vertex. So we just talked about the vertex is what, right? The tallest or the lowest point. So I'm just going to actually make this full screen because it looks like I don't even need a calculator. So the tallest point is right here. So it's 324. So the x-coordinate, so it's only asking for 2. All right. So this is the x-coordinate. What does it mean? So remember, I'm launching the rocket up 2 seconds have passed, it reaches the maximum height of 324, then it starts going down to the ground. So what does 2 mean? 2 means that after 2 seconds, my rocket has reached its maximum height of 324. And so that is what I am now currently looking for in the answer. So then when I look at this, it says how long it's in the air, the rocket's height. So first of all, if it's the x-axis, you can just look right here, time, right? So I'm not looking for height. It has to be time. So this is how long it's been in the air. When? Is it at its peak, which is another way of saying at the maximum, or is it when it hits the ground? Is this 2 at the maximum, or is it when it hits the ground? It is at the maximum. The y-coordinate or h-coordinate of the vertex is, so the y, this is the x, this is the y, 324. What does that represent? That represents, again, what is the y-axis saying? Height. So when you come into your options, of course, it's not going to be time. It has to be height. So what is it? The rocket height when? All right. Is it when it hits the ground, or is it when it hits the maximum? So it's at the maximum because this is when it hits the ground. Okay. All right, now obviously that's just the vertex, but I'm just going to go ahead and explain everything else while I'm here. If the question was, what was the rocket's initial height? It will be 260. What does that mean in context? It means the rocket was launched at a height of 260. Or you could say after no seconds have passed, the rocket is at 260. So remember, whenever we're interpreting, we need to use the numbers and then as well as what do the axes mean. All right, if I was interpreting this number right here, so I have 6.5, that's x, so I'm going to say something about time. And then I have 0, that's y, I'm going to say something about height. And then the only last thing I need is what's happening, so Natalie. So if I'm interpreting this, I will say Natalie, well, and you can do it in any order. So I can say after 6.5 seconds, so after 6.5 seconds, the rocket that Natalie launched is at 0 feet. Or I can say after 6.5 seconds, the rocket Natalie launched has hit the ground. Or I can say in a different order, Natalie's rocket hits the ground after 6.5 seconds. As long as you use 3 things, which is the number, then the what it means, what that number means, and then the situation. Okay, so I'm just going to do one more. This is just the vertex one. What does the vertex mean? So 1.5 is the x, so the x coordinate is 1.5. The y coordinate is 11.025, so the y coordinate is 11.025. And then what does it mean? So again, after 1, is this a rocket? It's a football. Okay, so Jamal kicks the football, so it's going to go up and then go come down. After 1.5 seconds, Jamal's football is at a height of 11.025. That's what that means. Okay, so that's what I'm looking for, but they split it up. So the 1.5, which is the x, which is the time, x is time. So you're looking for time, how long the football, how the football's height, so this is y and this is time, has been in the air at its peak because it's at the maximum, not at the floor. The y coordinate, which is now the height, right, represents the peak because it's at the maximum and not on the floor. My problem, increasing and decreasing are. So I'm going to do an increasing one and I'm going to do a decreasing one. So just hang tight until you get the one you need. So again, increasing and decreasing, there's a form that makes it easy, but it doesn't matter because what? I'm putting it where? In the calculator. So 2x squared minus 8x minus 24 right up into the calculator. And again, make sure you're typing exactly what you see, and that is why you double check, Miss Ainley. All right, so look at my mouse real quick. Okay, what is my mouse doing from left to right? What am I doing? Going where? Down. Until I get to what point? This point, and then I start doing what? Going up. So that's what you first have to ask myself, okay? I'm going down, then I'm going up. The shortest way that I know how to teach this is going to be real simple. What was that point of turn? It was my vertex, right? So let's start off with my axis of symmetry. So we know my axis of symmetry is x equals what? 2. And we're going to write that down. X equals 2. And it should produce my axis of symmetry. Boom. Because it splits my graph, right? On the left of it, it's going down. And then on the right of it, it's doing what? Going up. So all I have to say to tell the person who's grading this is whether it's the left side I want or the right side. And it depends on the question. So if this question is saying increasing, which side is increasing? Is it the left side or is it the right side? And you should have said the right side. Now just think about this for a quick second. Let me show you what the right side looks like. So this is the right side. Okay. Look at the inequality piece of going to the right. That's what you change the equal sign for the axis of symmetry to say greater than. And then you're going to do it in Desmos. Why am I doing it in Desmos? Because I want to make sure it highlights this. Because let's say I said it was 6. All right. Is it not increasing here? Yes, it is. So I know that I've made a mistake. So whatever it is, you're going to put your answer here so you can double check it. So it is increasing to the right of 2 when x is greater than 2. And that's what you're going to type right here. When x is greater than 2. All right, now we're going to also take a look at decreasing. And again, please don't try to memorize these problems because it will not work. It's going to change every single time. You see, this one is a U. Another one you may find an N. So let me see what this one is. Again, I'll choose a different form just so I can tell you it doesn't matter. So it's going to be -3. And then in parentheses, we're going to have x minus 3 and then x plus 5. All right, look, now instead of it being a U, it's an N. Okay, so that's what I'm saying. Don't memorize it. First thing you find is find the axis of symmetry. Boom, which is my vertex, right? So x equals what number? -1. I'm going to write that down. X equals -1. There's my axis of symmetry. Boom, it has split that thing in half for me really, really well. Now I just need to see which part is increasing and decreasing. So I'm starting on my left. Follow my mouse. What am I doing right now? Increasing, right? Till I get here. And then what do I start doing? Decreasing. So now I just need to know what is the question asking. So I go to the question, hey, Miss Amy, when's the graph decreasing? Well, I know it's not the left side because what's happening right here? Increasing. Then it starts decreasing. So I want to say on the right. So it looks like it's the same arrow. So I'm going to go ahead and change my equal sign to say, hey, the right. And boom, it shades it in for me. That is true. Everything on where it's shaded is doing what? Decreasing. Now let me just show you the other arrow. Let's say that the question wasn't asking where it's decreasing, but where it's increasing. So where is this increasing? Again, you start with the axis of symmetry. Excuse me. And then you say, where is it increasing? So it's increasing on this side. So I want to say that it's increasing on my left side. So here's my arrow. Look at the arrowhead. Go duplicate that on Desmos. So I duplicated. Did it shade the right side? Yes, it. So then I know that that's the answer. At every point on this graph, it is what? Increasing. Because after here, it starts decreasing. So please use Desmos to find an increasing and decreasing domain. So we just did this in the last one, but we'll go ahead and do it again just because I want to make sure that you're okay. All right, so when is it increasing? So it's increasing here up to where? Up to there. So where am I coming from? I'm coming from -infinity. So this is where it's increasing, right? Up to here. It stops right here. All right, so come down to that number. It's -5, right? And I need everything below that. So I can write that as a inequality with everything less than -5, or I like using set notation. It's up to you, doesn't matter. It's coming from -infinity, so it's going to be an open and closed. So it's coming from -infinity, and then it stops at -5, and we include that because it's shaded. Okay. So increasing or decreasing is just you're looking at where is the graph going up, where is it going down, and then you're writing in the x values for those points. I'm going to just straight put it in the calculator. So this is what we have in the calculator. All right, boom. All right, so the question is, when is it positive? That means it's above the x-axis. What does that relate to? So x is greater than 0. Sorry, not x. I apologize. Y. All right, so above the x-axis, above the x-axis. All right, so what part of this graph is above the x-axis? Do you agree that it's from here to here? At every single point between these 2 points, it is above the x-axis. So what I'm going to tell you is this. If it's joined together, like it's together like this versus separate, like this is below to here and then below to here, this is going to be one equation. If it is below, so let me give you the other situation. I'm going to do a below one. You can see that it's split up. It's below right here. Then it stops being below. It goes above. Then it begins to be below again. So these are two separate equations. So again, if your points are connected like this, that's one equation. If they're two separate ones, that is two equations. So before I show you how to actually answer this, I'm going to give you a few more examples of that so we can get familiar. All right, so remember, we're just looking at, this is my cutoff point right here. All right, so if I'm looking above, that's above the x-axis right here, how many equations do you see? 1, 2. If I'm looking below, that's below the line right here, you see that it joins together to be 1. All right, we're going to practice a couple more problems like that. So if I said above, how many equations do you see? 1, because it just joins together. If I said below, it's this point right here or this point right here. Let's practice a few more. Again, if I said above, so you look on the top, how many? 1. If I said below, how many? 1 and 2. Okay. All right, let's practice another one. All right, here's another one. So again, if I said above the x-axis, what do you see above? You see two sections, right? Here or here. And if I say below, then you see just this one section. All right, so I'm going to go back to my question. All right, so I'm going to go back to my question, and I've gone ahead and put the above or below. I'm going to answer both questions. So let's see if this is when it is positive. All right, so when is it positive? It's supposed to be above. So I'm going to shade that. So I'm going to do this real quick, greater than 0, so I can have a visual, right? So this is above. And how many bits of the graph do you see? Just one connected part. So because I see one connected part, it's going to be between these 2 points, which is between what? 1 and 5. All right, now I have two options on how to write this out. Okay, so I can say it's between 1 and 5. So what is between 1 and 5? X, my X coordinates, right? My X coordinates are between 1 and 5. Now I don't include 1 or 5. Why? Because it's negative, then at 1, it stops being negative and starts being positive, but there's this turning point. So you can include my turning points. All right, so it's between 1 or 5, and you can write it also as 1 to 5. All right, but one answer. Why? Because it's a continuous. So it's positive, one answer. Okay. Now, if the question was, when is it negative? Okay, my two numbers are still 1 and 5, but let's look at it. So let me change this to be negative so you can see it. All right, now I'm going to write my answers. Okay, so I'm going to say when X is is this to the left or to the right of this one? This graph right here. Is it on the left or on the right? I'm going to say left. And if you look at the arrow for left, it goes in this direction. So I'm going to say, hey, it's on the left of, what was that number again? Was it 1? It's on the left of 1. Did it shade the part that I need? Yes, it's negative right here. So it's going to be, this is for my example. Of course, you need to write yours. Negative on the left. So if I was writing in this notation, I would say X left of 1 or less than 1. Or I could write, hey, you're negative until you reach 1. So that means where you're coming from. Negative infinity, open, open. Okay. Or, so there's two answers because they're 2 times, right? Or it's also negative here, right? So how do I write that down? So let's try a different number. So we want to say 5. And you see it's shaded the wrong side because it's supposed to shade this black line, right? So I just need to change this direction. So you see, it's to the right of 5. So it's to the right of 5. Or you can say, hey, I'm going to start being at 5 because I start being negative at 5. And then when do I stop being negative? Infinity. All right, so this is going to be 5 to infinity. So you can see that you can use Desmos as a visual representation of your question. Okay, let me go ahead and try another question really fast. Maybe it's not letting me. So we're going to use Desmos to check our answer. And you can see I used a different form, so it doesn't even matter which form you use. So this is 3 parentheses x minus 3 squared minus 12. All right, cool. So here's my equation. And my question is, when is it negative? All right, so looking here, right? This is my point right here. When is this graph? When is the purple graph underneath my mouse? It is right here. So we can agree how many answers am I going to have? 1. If the question was
above, it'll be this answer here and this answer here. So we can use Desmos to check my situation. So I wanted to shade this negative piece right here. I want Desmos to do the work for me. So I'm going to grab my 2 points. So I'm going to tell Desmos, hey, it's 1 and 5. Hey, Desmos, graph, let's see if I do this right, because I know it's one equation. I know I need to do x is less than, or x is greater than 1, and x is less than 5. And perfect. You see, it shaded the bit I need. So this is my correct answer. Now let's assume that the question was, so this was if it was negative, it's negative here, one time connected. Now let me say the question is, when is it positive? I know I should have 2 answers. Where it shades this line here and it shades this line. So I'm going to try it again. So let's say x is to the right or greater than 1. Did it shade the line that I need? No, it shaded down here. So that's not it. So let's go ahead and try and change this around. So this is if this signs confuse you, you can use Desmos to check your answer and boom, it shaded what I need. So it's this or, the other number is what? 5. All right, let's try it. Let's try it this way. Ooh, no. I don't want you to shade this. I don't want to shade that. I just want you to shade this part of the line. Let me zoom out a little bit so we can, boom. I need you to shade this part of the line. So that must mean I must have the wrong directions. Let me change it right there. Change the direction to the right and it works because you see, now my shaded part is a positive. So what's the only thing that's shaded, look, is my positive side right here and right here. None of my negative is shaded. And that's how you know that your answers are correct. Again, the big takeaway when you're looking at positive is you're looking either above the x-axis, below the x-axis, and your answer will either have one equation if it's connected or 2 separate ones if it's disconnected. Let's practice. All right, we're going to take a look at select form to find quadratic feature. Okay, and we're only going to look at 3 things: y-intercept, x-intercept, maximum, minimum. Because for increasing and decreasing, all you have to do is just type in. It doesn't even matter which one. Just select one, type it in, and then you can do it off the calculator. So for those, you can look back to how do I do increasing and decrease and positive and negative. The only ones I need to go over is this. Now, y-intercept. Technically, let's be honest, you can just type it in any of them, right? And then you can see the y-intercept. But I quickly want to explain because sometimes they're going to write this question in such a way that you have to know which one is best, okay? So a quadratic function is hidden from view. You must find the y-intercept of f of x and write the answer in the form xy. Choose the form of the quadratic fraction you'd like to see in order to answer the question most efficiently. And that's what the question is going to talk about, is the most efficiency. Technically, because we have Desmos, they're all efficient. However, most efficient is the one you can do the fastest. So now we're going to talk about the 3 forms that we have and what they do. So we're going to start off with vertex form because that's the easiest. What do you think I can get really quickly from vertex form? Well, I can get the vertex. How do I get the vertex? I pull the x coordinate by taking the opposite. I pull the y coordinate by exactly what it is. Okay. All right. For the rest, factored form, you should also know this one. 2 parentheses. This is where it crosses what? The x-axis. Therefore, this is going to give me my x-intercepts. And how do I pull my x-intercepts? Again, anytime you're inside parentheses, you're going to take the opposites of whatever number is in there. So there are 2 x-intercepts. And just so you know, in quadratics, you could have 0, 1, or 2. In this case, there'll be 2 if there's 2 parentheses. All right, and then so finally, the last one is y-intercept. That you're going to get from standard form, and it's the number right at the end. Now that we know that, we are not going to use Desmos, okay, because of the way they sometimes word this question. But you can check your answer with Desmos. In fact, that's exactly what I'm doing. All right, so I'm looking for y-intercept. What form would I want to see? Well, vertex is going to give me the vertex. Factored is going to give me my solutions, which is my x-intercept, so it must be standard form. And what is it? It's -9. It's the number right at the end. So there is an x-intercept, there's one y-intercept, sorry. And in coordinates, because it says write it as a coordinate, it's going to be 0 is the x and -9 is the y. And I'm just going to quickly check that by typing it in. All right, so what's the y-intercept? Boom, 0, -9. But you see, because this question says most efficiently, you see how long it took me to type it in? It would take too long. Most efficiently means the fastest way you can do it, which is just by looking
added and seen -9. So I'm not even going to check it now. I'm going to most efficiently do it. However, if you're doing this in a test, please definitely check it, because you don't want to assume that you know it and you don't. Okay, so I'll do x-intercept now. All right, so which form do I want for x-intercept? All right, so I check this. Again, this is vertex factored. Remember, it's solution, so that's my x-intercept, and standard is my y. So I go factored form, and I pull it. It's going to be +3 because it's x and opposite, -1. I already know it. So I'm going to come here. How many x-intercepts are there? 2 of them, because there's 2 solutions. So I do boom, and I go +3, and then 0, because of the x-intercept, the y is 0. And then I go -1, comma, 0. And again, you can type it into Desmos to double check. I'm just not going to do that. All right, so I'm going to pull up another one. This time I want to find a maximum value. What is a maximum or minimum? The vertex. So again, I come here, vertex form. Okay, I click vertex form, and how do I pull it? This is the x. Just remember, take the opposite. And this is the y. So what do I want? I want a coordinate. And the x is not +1, but opposite, which is -1, and the y is 16. So again, most efficient. Ooh, what did I do? Yeah, it was -1, 16. What did I do? The vertex is at -1, 16. Oh, I didn't read this. And this is a great point. In fact, listen, this is a great point. Did it ask me for the vertex? No, it asked me for what? The maximum value. So remember, we just talked about this in a previous Delta math. It asked me for the maximum value, which means I don't care how wide you are at the ride. I only care how tall you are. So therefore, the maximum value is 16. Oh, yes. Make sure we read the question. I just assumed, to be honest, that's really bad. All right, find the maximum value. Okay, so this is asking for the maximum value again. So it's going to be the vertex. All right, what is the maximum value? Well, I know the vertex is -1, +27, but I don't care how wide I am. I only care how high I am. So this is 27. Wow, reading the question is fundamental. Okay, fundamental. All right, this one's asking for the y-intercept. So what form do I want? I want standard form, and the y-intercept is that, and it wants me to write it as xy. So there is one y-intercept. All right, the x value at the y-intercept is 0, and the y value is -42. Close the parentheses, and we are good to go. All right, so that's how you do select form. All right, so now we're going to interpret quadratics again. This time, instead of looking at the vertex, we're going to look at appropriate domain. Okay, so it's real context domain. So Eximena, I don't know how to say that, launches a toy rocket from a platform, so that's something that's going to go up and come back down. The height of the rocket is given by this, so let's go ahead and type that in. Remember, does T ever show up? I don't know if T shows up. I'm going to type in T and C. Plus 40T, and then plus 96. There's an error, click the error, try adding y equals. Okay, so T shows up if you add y equals. So it's really up to you however you want to do it. You can make it X or you can make it T. I'm going to click home. It makes sense. The rocket's going up, then it's coming down. But this is domain real world. Now, a couple of things. See how I can't see the whole thing? I have to kind of scroll to see. All right, we talked about how I can, well, I'm just going to zoom out. I can zoom out like that and my graph is really small, but we also talked about how we can kind of change what is my x-axis and my y-axis and what it's going up by. So if I look at this, my vertex is going to be on my y 130. Okay, so I can change my y-axis instead of going up by 1 so I can see it. Let me say it goes up by 10, for example. All right, so now it's going to go up by 10. See that? It goes in a little faster, and then I can hide these minor grid lines so I can see. Right? So now I can really see, I can see it clearer. Even if I zoom in, it doesn't change, right? I can make it go up by something else. So instead of 10, let's make it go up by 20. Like it zooms in even more. So now it just becomes like, now I can see the whole picture. So you can do it like this, or you can leave it zoomed out. Since I've already zoomed in like this, I'm going to leave it like this for now. Don't worry if that just confused you. You don't have to worry about it. I'm actually even going to, I can change the X. So you see how it goes to 4 and it starts at -1.5. So I'm going to say, hey, x-axis right here, start at -2 and go to 4. So I'm going to say go to 5. and go up one by one. So it's going to go 1, 2, 3, 4 like that. And you see it makes it even wider. So it just becomes a clearer view. But again, you do not have to know how to do this. Even if I zoom out, you see it's still clear. So I'll do one question like this since I've done this, and then the second one I won't do that. All right, so where t represents the appropriate time in seconds. So x-axis is t and y is h. What's the appropriate domain? So what is domain again? X values from left to right. So I'm only looking at the x-axis, right, from left to right. So here there's a graph everywhere, but this is a real world situation. What does the x mean? So x, right, or t, represents the time. So can I have negative time? Absolutely not. So I can start at 0. Can I start at 0? Yes. When I launch the rocket at 0, I guess I'm launching it from like a platform or a building or something like that. I'm at a 96 height. So I'm launching the rocket from here. It's going to go up and it's going to go down and it's going to hit the ground right here. Is it going to go inside the ground? Absolutely not. So I do not pass 4. So my appropriate domain in real life is going to be from 0 to 4. Now there's a few ways that you can write that. It's 0 to 4 included, so I can do it this way, 0 to 4 like that, closed because it's included. Or I can do, now I can't use x because this is using t, so I have to use t. So I can do t like this from 0 to 4 because I'm including it. Okay, so let's see, why is that wrong? It's 0 to 4. Or did I do, oh, I hit this by mistake. I meant to say less than and equal to less than or equal to. That's my bad. All right, so really just use this notation so that you don't do that mistake. I didn't even pay attention that that's what I hit. All right, so just be careful. All right, similar problem. All right, so minus, it's going to be minus 16 t squared plus 112t. And if you're curious as to why I know it's always minus 16, it's because gravity makes it to where the projectile motion question is always minus 16. All right, nothing showing. Try adding y equals because I totally forgot to do that. Y equals. All right, now I see it. Now I'm not going to change the thing because now we're just going to do it this way. So again, the rocket goes up and then it comes down, right? All right, so the appropriate domain. So because the domain is x-axis left to right, and this is a real world situation, in other words, it's a context problem, I'm going to have to look at what x means in order for me to see. So this is the time in seconds, which means if I'm thinking about it, so I'm only going to see the x-axis. And if I'm thinking about it, I cannot go from negative 0.5 because I can't have negative 0.5 seconds. So I do not count this. I have to start counting this as the y-intercept, which is really hard to see with this. But if you go here and click in here, it should have a dot appear. Wait, there it is. So if you're not zooming out or in, you click in here and then you click the dot that appears for y-intercept. So that's where I start, is from 0, time is 0. And where do I stop? When it hits the ground. Now the question is, can I have 7.5 seconds? Yes, I can. So I actually forgot to mention that in the previous example, when you're looking at real world domain, sometimes you can't have half. So for example, if this was maybe about people, I couldn't have 7.5 people. So this real world domain is from 0, 0 included, to 7.5. Okay. Now, I'm also going to give you another example. Let's say I had, so if we're doing real world domain, let's say I had temperature. If I had temperature, I could include these negative numbers. So it goes on forever on the left side because I can have negative 0.5 Fahrenheit, for example. All right, so you just have to think about what it's asking for in the context of the problem. All right, so I'll just do one more. This is plus 64t. All right, there it is again. Okay, so it goes, whatever, the rocket's going up, it's coming down. What's the appropriate domain? Because again, it is still talking about time. I can have 0.5 time, but I can't have negative. So I can't go, let's see where this thing is. All right, so where's my x, my y-intercept? That's going to tell me when time is 0. So you click it. Oh, my y-intercept is at 0. And then I can't pass 4 seconds because after 4 seconds, I'll be at negative height. So it's from 0 to 4. So again, just be careful with domain to think through the problem according to the definition. So they're going to tell you the x-axis is something and the y-axis is something, and you have to ask yourself if that number makes sense.
All right, I think I went through all those definitions. All right, so we're going to take a look at finding average rate of change from a table, equation, and a graph. And really, if you can do one, you can do all. All right, the table is easy. So remember, average rate of change, you need box. So in my case, you're going to do parentheses. Then it's parentheses minus parentheses over. So I'm going to do divided first. So you got to do divided so I can do that. Parentheses minus, parentheses minus parentheses. All right, then minus parentheses. So once you have that set up, parentheses minus parentheses over parentheses minus parentheses, they're always going to give you the x values. And remember, we're going off of, what is this? Slope, right? Average rate of change. So if you go look right here, average rate of change, it says the change in the y divided by the change in the x. And if you look to the left, they give you the values. So you can see x on the bottom, y on the top. So x on the bottom, so x, and it looks like it's which x? X2 first, so the second one. So the second one is 13. So 13, and then the first one, which is 4. So x on the bottom. Then all you have to do once you put that in is match it for the y. So I'm going to go look for 13 in the table. Right here, what's the y value? 30. So you're going to match that to 30. Then you're going to match 4. What are you going to match 4 to? 48. Once you put it in, that's your answer. You're done. All right, so that's from a table. Then when you do it from a equation, it's the same thing. You're just going to copy and paste it. Control C. And I'm going to leave this up here because I need it. Control V. All right, then, fix whatever needs to be fixed. Like, I don't need that at the end. All right, something has come up. All right, so once I get an equation, now that I know how to do it from a table, all I need to do is make this a table, right? To make that a table, click on the settings, hit table, and now it's a table. And now you're looking for your intervals again. So once again, I'm going to delete this. So it's parentheses minus parentheses over parentheses minus parentheses. Make sure that that's what it is and not this. This is something different. If you have this would be wrong, okay? So make sure that that division bar goes over the whole thing. All right, so now I'm looking for, again, the first number, if you forgot, is the second x and then the first x on the bottom. So second x is 11. So that goes right there. First x is 3. And then match it. So I don't see an 11 here. Oh my gosh, just come in here and type it. 11 is 21. And then 3, if I don't see a 3 there, just come to any number, type 3, it's 53. So once again, it works it out for you, and that's negative 4. All right, so all these questions are really the same thing, but from 3 different values. So we're going to take a look at the last one. All right, so looking from a graph, again, the same kind of idea. All right, so what's my second? So I'm going to come to my boxes here or my parentheses and delete all the numbers. All right, and they tell me my second one is 2. That goes over here. And again, if you forget, just come to formula sheet right there. In fact, I should do this. All right, so right here, the second one goes first in the bottom. So 2, and then the first one in here. And you just have to find what those matching equivalents are. So when x is 2, what's y? So when x is 2, right here, y is 0. When x is 1 right here, I go up to the graph, y is 10. All right, so again, to read the graph, you just go to it. So when I'm finding x is 2, I go right here, y is 0, y 1. When x is 1, it's 10. If x was 7, I'd go to x is 7, go to the graph, and then y would be 40. If x was negative 2, for example, I'd go to negative 2, go to the graph, and y would be negative 32-ish, but they won't ask you for something in between. And that's pretty much how you do all of those questions. So you can do all of those questions relatively fast.
All right, so now that we've looked at average rate of change using the formula, we're going to do average rate of change using the calculator. So again, according to the formula, average rate of change is the change in the y value, which is this part right here, the change in the y value, divided by the change in the x value for 2 points, for only 2 points. Okay, so these 2 distinct points are very, very important for only 2 points. Okay, so it's really just finding the slope okay, for exactly 2 points, not for all the points, 2 points. All right, so once you know that, it becomes relatively easy. So I'm going to do it from all representations. So there is a graph, a table, and an equation. So we'll start off with a graph. Again, I need average rate of change, the slope for 2 points. I'm going to make a table. I'm going to get 2 points. They always give me my x values. So my x values are from -2 to 3. So -2 and 3. And I just need to find my y value. So -2, my y value is 0. And then 3, so it goes 1, 2, 3, my y value is -20. Once I have my 2 distinct points, I'm just looking for slope. So slope for f of x, and I'm going to write it here just so I can keep track since I'm comparing. My slope for f of x is -4. Okay, so I'm just going to keep changing because the 2 distinct points are not going to change. So I'm just going to keep changing what my average rate of change is. From the table, I just look at it. So again, I'm looking for 2 distinct points. So these are the 2 points. -2 is equal to 10. And 3 is equal to 5. Again, you do not put more than 2 distinct points. This letter is g of x. So g of x is equal to my average rate of change is -1, which is my slope. All right, the last one is an equation. So for that one, I'm going to need to type it in so I can see what the actual equation is. So I type it in just like I see it. All right, and I need my 2 distinct points. So I need to see the points. How do I see the points? By making it a table. And the only points I care about are -2 and 3. So I'm just going to type -2 and 3. And now I can't click the slope here because these are not 2 points. This is 1, 2, 3, 4, 5, 6, continues forever. So I'm going to put it on my 2 distinct points. It should be 31 and -9. So 31 and -9. Again, 2 distinct points, only 2 points. That slope is -8. So h of x is -8. So my slope is -8. Now that I have all 3 of them, I'm going to answer whatever the question is. So the question could be, and I'm going to go ahead and say this, which one has the fastest rate of change? They don't care the direction it's going. They don't care that it's negative. They just care which number is the biggest without it being negative. So the absolute value. So the fastest rate of change would be h of x. All right. However, in this one, you're going to put it from least to greatest. Okay, we're going to put it from least to greatest. So least will be -8. And look at that, I'm organizing it here. -4 will be second least. The greatest one will be -1. So I'm looking for HFG. HFG. Okay, so I'm going to do one more. So again, average rate of change is slope from 2 distinct points. So to find slope, I need the 2 points, and they're always going to give you the x. Sometimes not written out like this, it's in words. Maybe it says the first 3 seconds. So if it's the first 3 seconds, it's from 0 to 3, something like that. All right, in this case, my 2 distinct points are -4 and 6 for the x values, and I just need to find them. So for f of x, when x is -4, go to the graph. It's right here in between. And how is it going up? It's going 5, 10, 15, 20. So again, when x is -4, it's right in between -20 and -30, so that's -25. When x is 6, I go to the graph again, y is -10. So my slope for 2 distinct points, because there was only 2 distinct points, is going to be 1.5, which we need to turn into a what? A fraction. So you type it in, click fraction, so it's 3/2. So 3/2 is my f of x. All right, so now that's done with f of x. So from a graph. From a table, I can just see it. So -4 is 57. 6 is 17. So my average rate of change for g of x, from 2 distinct points, only 1, 2, is going to be -4. All right, and I'm going to go ahead and order this from least to greatest. So this one's going to be that. And then my last one, which is h of x, is from an equation. So I just need to type the equation in so I can see what the points are. All right, so that's the equation. I need to see what those points are, so I'm going to make that a table. Then I'm going to find the two distinct points I need, which is -4 and 6. So -4 and 6. And I'm not going to click the flag here because this is more than two distinct points. So I'm going to go 78 and 18 in here. 78 and 18. So my average rate of change for h of x for two distinct points is -6. Now I'm just going to put this in order. So the least is going to be this one. All right. So from least to greatest, it's in order with negatives. However, the fastest rate of change, they don't care which direction you're going, whether you're going, like if you're driving a car, whether you're going, maybe you're racing forwards or maybe you're racing in reverse, it doesn't matter. It's just who's going the fastest. So that keyword fastest means I don't care about the negatives. So this would be the fastest. However, from least to greatest in order, I do care about the negatives. So that is from least to greatest, and then that's what I'm looking for, HGF. You can get for this compare ones. So it really doesn't matter if I do one or two. It's just a matter of you reading and understanding the question. So answer the questions based on the graph of the function f of x and the table of g of x. So here are my two functions. And the question is, what is happening in the y-intercepts? All right, so again, there's just no way of knowing what question they can ask you. If it's a graph, you can easily see what's the y-intercept here, -5. Okay, what's the y-intercept from a table? If you don't know that the y-intercept right here happens when x is equal to 0, so when I go look at x equals 0, it's going to be -6. It's a matter of you knowing how to input the table. So let me just show you how to input the table just so that we're all clear. So this is -4, 2, -3, 0, -2, -2, -1, -4, 0, -6, 1, -8. All right, so here is the table. Now, it looks linear to me, so guess which equation I'm going to look first? We can click this to zoom fit it. I'm going to check y equals mx plus b. Again, two things you need to change in Desmos. You need to put the 1, well, is it 1? It is 1 and 1, so 1 after the x and y, and you need to put it in the squiggly line. As long as it goes through all points, you know that that is exactly what it is. So does it go through all points? Yes, it does. So this is actually the equation, which is, I'm just going to copy this real quick without the squiggly line and without all of that. So this is y equals mx. M is -2, so we're going to put -2. And b is -6. All right, so this is my equation. All right, where's the y-intercept? So we're going to come see where it crosses the y-intercept, and you can see that it crosses at -6. So it's a lot faster if you know how to read a table, but if you don't know how to read a table, that's definitely how you put it into the calculator. And so what was the question? The y-intercept of f of x is, so which one is which? This is f of x, so -5 is greater. Oh, they're just answering what it is. Okay, cool. -5 is, so f of x is -5. G of x is -6. Therefore, f of x has what? Greater. Be careful with negative numbers, okay? It goes -10, -9, -8, -7, -6, -5. So everything to the right is greater. So that's greater than. All right, but again, like I said, there could be a trillion answers they could ask out of this. So you can see that one was y-intercept. This one is x-intercepts, where it is across the x-axis. All right, so I'm just going to talk about it. This one is y-intercepts. Let's see what else you can get. So here is a graph and here is a table. What you want to do is find what? Questions below. Okay, so here's a question. All right, the maximum or minimum of f of x. So really important that you just know how to read the graph. So this says f of x, right? So when you're answering f of x, look there. And when you're answering g of x, look here. All right, so f of x. So let's take a look at f of x. Does it have a minimum or a maximum? So it has a minimum. Of f of x is, so what's the minimum value? Remember, it's just the y value, right? Which is what? -7. So the minimum value is -7. And there is no maximum because it's a minimum. Okay. Now I don't know if this is a maximum minimum, and I could show you how to put it, but I'm just going to show you since we're showing you via cheating. We're going to show you via cheating then. We're going to commit. All right. To put in a table, you're going to click table. So plus sign, table. Put in your values. Just make sure that you're very careful that you put them in correctly. All right. So if I keep pressing enter, it keeps putting it in right. Then come right here. So it goes 6, 1, -2, -3, -2, 1, and 6. And you can already see it's a what? It's a minimum, right? So this one is the minimum value, and I need to know what that minimum is. So I can kind of guess these points, but I don't know if this one is the correct one. So I'm going to double check. To put that in, I know this is a quadratic. So what you have to do is you have to put in a quadratic equation. What does a quadratic equation look like? AX squared plus BX plus C, right? Now, here is the issue. See, I have an error. What it is it's saying, hey, there are too many variables, okay? Cool. I'm going to look on this table. I'm trying to tell the calculator, hey, look at this table and tell me the answer. So notice in the table I have X1 and Y1. So I have to tell this calculator, hey, it's supposed to be Y1, and everywhere there's X, X1. All right, I still have an error, and this is the only thing you really have to remember is for whatever reason it doesn't like this equal sign, you're going to click ABC and put squiggly line. All right, so ABC and quick squiggly line. As soon as you do that, notice what happened. It drew it for you, right? So now we can zoom in because it drew it for you. And my point is -1, -3. How do I know that? I'm going to take the equation again. All right, let me make this bigger actually. I take the equation again, and now I'm going to put it back to, the y equals, because now I have the answers. I want to show you I have the answers, so give me a second. Boom. Okay, cool. This is the standard form, right? It tells you A is 1, so when I come right here, A is 1. And notice this black one should be the same as this red one, even though it is already. All right, 1, B is 2, and C is -2. Right, so notice how it's the same thing. So if it doesn't happen to give you one of the vertex points, I can see clearly it's -1, -3. So once you put in the table, so it's -3, my y value. There is no maximum because it's a minimum. I can just see it. All right, therefore, which one is bigger? All right, so f of x is -7. F of x has a smaller. So let's go up here. See, this is at -7, right? -7, this is at -3. So f of x has a smaller minimum, right? Because it's smaller. It's at -7. If it was bigger, remember with negatives, right? The smaller the number without the negative, the larger it actually is. So bigger numbers are up here. So this is -7, so a bigger number, -3. All right, we're going to do another question. And this time, since the table is already there for me, I'm not going to erase this. All right, so going to another problem. So I'm actually not giving you any of these, but you do the same thing. Put it in, look at the y-intercept, put it in, look at the x-intercept. But all I needed is actually a maximum and minimum. Comparing extremes of graphs, equations, and tables. Okay, so we're going to compare this, put this in order from smallest minimum to largest minimum. So take this. This is f of x, put it in here. That's f of x, right? So you can already see the minimum is -4.5. We need a table, so we're going to come here, make a table. All right, so I have -4, -3, -2, -1. Then here I have 0, -2, -2 again, 0. And again, from a table, it's probably faster to do it forwards, but I am going to, again, like I said, I am going to show you. So again, we're writing in quadratic feature. So what does this look like? It's supposed to be y equals ax squared plus bx plus c. And it doesn't like it because it needs to reference this. So be careful. Sometimes it's not always 1, but in this case, it is 1. So wherever I see x and y, they're both 1. So everywhere I see x and y, I'm just going to go click on it and press 1. Still doesn't like it, and that's because of this equal sign. It doesn't want the equal sign. You're going to press ABC and do the squiggly line and delete the equal sign. Once you do that, you can see automatically it gives you a graph. I don't like red because they're both red, so I'm going to copy and paste it out again. So now it's in blue, right? So this is in red, this one's in red, This one is in blue, so you can see where the minimum is right there, right? This one, the minimum's right here, and the last one, the minimum is right here. So we're putting this in what? Smallest to minimum. Smallest minimum value to largest. Okay, so the one that's smallest is the furthest down, right? The smallest is the furthest down. So the one is this one is -8. What's this one? -4.5. So this one is this furthest down. So h of x should be first. So one of these two options. Next will be red. So red is this value right here. So I go back to see this value right here is f of x. So it should go h of x, f of x, then g of x. All right, so again, all you got to do is put them all in and look at it. Okay, so let's do a new one. All right, so boom, copy, paste. All right, squared. Make sure you copy it directly. Boom. All right, I'm going to change this table right here. So I guess I'll just X out of that. All right, I'm going to leave this here. So I'm actually going to control X, but I'm going to come back to it. So put in the table. So this is -1, enter, 0, enter, enter, enter. And then on -1, it's 1, -2, enter, -3, enter, -2, enter 1. All right, so again, I had copied the equation, right? Because it's y equals ax squared plus bx plus c. Make sure the ones, oh, see this? It's not 1 anymore, it's what? 2. This was a perfect example. So make sure all these numbers are changed to 2. So they all need to be 2. Otherwise, it'll give you the wrong answer. So 2, because you're telling it, go look at this table, right? So 2, so that's the purple one, and then the last one is right here. And what are we looking for? Minimum values? Okay, cool. So the one that's the furthest down is the minimum value. So let's see. This one's -7. This one is -8. So this one wins. Green wins, which is this vertex form, which is f of x. So f of x first, one of these two. Then second would be, this one is -7. This one is -3. So -7 is next. So h of x. So it goes f of x, then h of x. And that's all you're doing. So just put it in the calculator and compare it. All right, so we're going to take a look at comparing extremes of equations, graphs, or tables. So extremes mean looking for the minimum or the maximum. And remember, it's not the vertex, but just the minimum or the maximum. So again, when I go to Six Flags, what's my minimum height? What's my maximum height? I don't care how wide I am. So just the y values. All right, so this one, I can quickly get it. It's -4 if you watched the previous video, but it's okay. You can go ahead and type it in and just look. So f of x is equal to x plus 1 squared minus 4. And you're going to see that the vertex is going to be -1, 4. If you want to know how I know that quick, go to select form, y-intercept vertex, and x-intercepts. So -4, that's that one. So just to keep track of this, I'm going to go ahead and type it in just so that I don't make a mistake of getting confused or forgetting. So that's f of x. Now I'm going to go to g of x. G of x is equal, oh, there's a table, I'm sorry. It's not even an equation, but okay, so that's g of x for that. I'm going to put it in as a table because it's a table so I can see what it is. And then I'm going to type in the whole table. Now don't be lazy, type in the whole table. -3, -7. All right, we're going to zoom fit. So I'm going to hide this so you don't see that. So we're going to zoom fit right here. And it looks like a U, but we're not sure. So we're going to try different things. If it's linear, does it go through all the points? It does not. So we're going to try quadratic, and that fits perfect. And if it wasn't quadratic, the other one that we deal with is exponential. Okay, so it is quadratic because it goes perfectly through every point, which is why you have to zoom fit. So this is my quadratic equation. So I'm going to copy that, and that is my g of x. Actually, do I even need to? Yeah, I do. So I'm going to copy my equation. I can now get rid of my table. The reason I copied my equation is so that I can click on the vertex. So again, remember, I don't care how wide you are, just how tall you are. So it's -7.25. So g of x is -7.25. 25. And I'm just going to confirm that again. Yes. All right. So now when I put in this, in what order am I putting? In order of smallest. Okay, so smallest number between -4 and -7, G is smaller. I'm going to hide all of those, and then I'm going to go to the last one, which is a graph. So I'm just looking at this minimum, and it doesn't have to be exact. So this is the graph of h of x. So I'm going to put it right here so I can compare. H of x is equal to, all right, this minimum is like just over a -6, but not even halfway. So not it's under -6.5. So let's just call it -6.3. Okay. So again, we're putting this in order from smallest. All right, smallest to largest. So this is the smallest, then -6 is smaller than that, then -4 is the largest. And now we're just going to go look for that. So it should be GHF. GHF. All right. I'm not going to do a whole bunch of these because I've done this within the unit. Now you're just doing 3 of them in one question. All right, so moving on to the next one. All right, so we're going to do compare linear features equation. So we're going to compare different things. So there's comparing x-intercepts, y-intercepts, and slopes. I'll start with x-intercept. So how do I find my x-intercept from an equation? I type in the equation. And I make sure that I'm typing exactly what I'm seeing. Boom. And how do I find the x-intercept for that? I go click on it. So that x-intercept is 8. So line A equals 8. And I just need to find line B. How do I find the x-intercept from a table? Well, if I know my x-intercept happens when y equals 0, but again, just to be foolproof, I'm going to put it in the calculator. So -6, -1, -4, 0, -2, 1, 0, 2, and 2, 3. Please make sure you type everything. Do not be lazy. Go ahead and make the line so we can see it. And that's my x-intercept, which is -4. So line B is -4. So line B is -4. That's my x-intercept. All right. So let's answer the questions. The x-intercept of line A is 8. The x-intercept of line B is -4. Therefore, the x-intercept of line A, so therefore 8 is not equal to, not less than, but greater than line B. All right. Now, let's say we were asked to compare y-intercepts. I mean, it's literally the same thing. You're just looking at a different part of the graph. So you type it in. I don't care what the equation is. Just type it in. Equals -x minus 4. All right. Then I'm going to see what, this time it's what? My y-intercept. So that's 6. So line A is 6. And then I come to the graph of line B. So I go line B. And I write it as notes. Like if you had a scratch sheet of paper, you'd be writing it on paper. The y-intercept for this one is -5. Then I go answer the questions. The y-intercept for line A is 6. The y-intercept for line B is -5. Therefore, now you're just comparing the y-intercept for line A. So 6 is bigger than -5. That's what I'm looking for. Greater than -5. Okay. Last one I will compare is slopes. So again, I'm going to put it in. Y minus 2 equals -2 over 5. Again, make sure you're typing exactly what it is, not what you think it's saying, but double check. All right, how do I find the slope of this one? Let's see, what can I do? I can make it a table. Nope, I can't make that a table. So what can I do to find slope? Well, it looks like since I can't make it a table and there's no flag, I can get 2 points. So here are my 2 points, right? Then I can put it into a table, and those 2 points are -5, 0. And I'm just going to show you, just in case it's not this one, I'm going to zoom in for another one. Please remember that to make this less confusing, you can take off minor grid lines. You can click spanner, minor grid lines, so that you see corners really clearly. And I'm just going to go, not this corner, but I'm just going to go to a different corner right here. And then put my mouse slowly. So it looks like 5, -4 until I see it. 5, -4. So here's another point, 5, negative 4. And then I'm going to make it what? Flag. And then I can see my slope is negative 0.4. So this is for line A. So for line A, my slope is negative 0.4. For line B, okay, so again, I'm looking for a table so I can see what the equation is, and I just need 2 points, 2 corners. So if it crosses the x and the y, of course, pick that, but I want to make sure that I'm teaching you how to get these points. So to read this, it's always x and then y. So this is 1, 6. All right, so always use the easy ones though. And the next one is 2, 8. Then I click the flag. Then I click the slope, which is 2. And then now I compare them. So the slope for line A is negative 0.4, which needs to be a fraction, which you type it in and click it, is negative 2 over 5. The one for line B is equal to 2. Therefore, this one, so line A, this is smaller than B. That's what I'm looking for, less than B. Okay, so we're going to take a look at comparing two linear functions in context, in other words, word problems. There are a few kinds of word problems that you could get. We're going to go through all of them. So I'm going to start with determine y values of function equality, whatever that is. All right, so I'll put it on the side here because what I want you to do is obviously highlight some things. But on a snow day, Nathan created 2 snowmen in his backyard. So snowman A. So there are 2 of them, and this is the first one. It was built to a height of 37 inches. And snowman B, and I'll just change the highlighter color, was built to a height of 49 inches. Okay, so they both start with 37 and 49 respectively. The next day, the temperature increased and both snowmen begin to melt. And so remember, anytime something is melting, your slope is going to be what? Negative. At sunrise, snowman A, so that's going to be pink, snowman A decreased by 3 inches per hour. Snowman B, which is my green, is going to decrease, because it's melting, by 4 inches per hour. All right, let A represent the height of snowman A. So I'm going to type that in here. So capital A, if they say A, you're going to have to use that. Height of snowman AT hours, so it's A of T, if you're writing this in function notation. And then let B represent the height of snowman B, T hours after sunrise. And because it's capital, you're going to also make sure it's capital. So you got snowman A, snowman B as a function of time. Write an equation for each situation in terms of T and determine how tall each snowman is when they are the same height. Okay, so there are 2 things that we need to do. I'm going to reset my calculator because I forgot this is on the last question. So give me a second. So snowman A and snowman B. All right, so I need to write a function or an equation for snowman A. So remember, when you are writing a linear function, you have y is equal to mx plus b, where m is slope, or the number that keeps happening every something, every hour, every day, every month, every year. Okay, that's slope. And then plus b is your y-intercept. That's the number that happens one time, your start or your initial. Once you identify it, you're just putting it in the equation. So again, what is the number that happens once, or what's my start? And then what's the number that keeps happening, and pay attention to the symbol. All right, so I'm going to come back here. So snowman A was built at a height of 37. Is 37 happening repetitively over and over again, or is it the number we start with, or is it the number that happens one time? All right, you should say it's the number that happens one time. So it's plus 37. All right, so that means snowman B also has a height of 49. So I start at positive 49. Snowman A's height is decreasing 3 inches per hour. That means hour 1, it goes down 3. Hour 2, down 3. Hour 3, down 3. Hour 4, down 3. How do I represent down? Negative 3. And then because this is a function of t, do not put x, but put t. All right, for B, it's decreasing 4 inches every hour. So hour 1, 4 inches down. Hour 2, 4 inches down. Hour 3, 4 inches down, and so forth. You're going to say negative 4. And again, you're not going to put x because it's not mx plus b, but it is a function of t. All right, so those are my 2 functions. So there are 2 things that I need to do. I need to write my functions. So I've done that. And then determine how tall each snowman is when they're the same height. Okay, so these are going to be the same height at some point. So I'm going to press home. And where are they the same height? It's where the two lines intersect. So they intersect here. Now you have to remember what's what. This is time. So at 12, is this hours, minutes, whatever it is. At 12, they are one whatever height. So now I know what it is. So I'm going to say at, oops, I didn't mean to do that. At 12, comma 1, so that I can keep track of what that is without looking. So right there at the intersection. All right, then I'm going to read it in terms. So I know T hours. So this is 12 hours and one tall height. What's the height? 37 inches and 1 inch. Okay, once you know that, now we can answer the question. So the function of A, okay, and so you see, sometimes they don't put as a function of T, but make sure you don't put X, but you put T. So negative 3T plus 37. Function B is negative 4T plus 49. And then your answer is it's 12, 1. But what were they asking for? How tall. So I don't care how time, I care about how tall. So 1 inch. And let's see what this says. All right, now you got to say what it is. So how tall is 1 inch? After 12 hours, the snowman is 1 inch tall. All right, now we're going to do a different one. So select X. All right, a small town has 2 local high schools. High school A, so high school A, and obviously it must be high school B, but we'll read. Currently at 550 students, and it's projected to grow. Okay, school A is at 550, and it's projected to grow by 70 students a year. So again, we have Y is equal to MX plus B. M is the number that keeps happening, or it's the rate of change, whereas B is your initial, your start, or the number that happens one time. So looking back at the question, it says it starts, oh, sorry, I'm telling you the answer, but 550, is it that number that it starts with, happens one time, or is it the one that keeps happening every something? You should say that it's the number that happens one time, so this is plus 550. All right, it's projected to grow. What does grow mean? Plus, okay, so your slope is also positive. 70, right, students each year. That means year 1, 70. Year 2, it's going to grow another 70. Year 3, it's going to grow another 70. Year 4, it's going to grow another 70. That's how you know that's the slope one. All right, each year. Now, it doesn't tell me a different letter, so I'm going to put X for right now so I don't forget. High school B is currently at 650, so they start with 650 students, and then every year, so that's my start, every year it grows by 50. So again, also growing is positive, 50, X, okay? Let A represent the number of students in high school in T years. Okay, so there's that letter. So again, you can't choose X, you must use whatever they tell you. So in this case, it is T, so make sure you use that. And B represent the number of students in high school B after T years. Okay, so what they're saying is X is going to represent students, and then, sorry, not X, T years, sorry. T is going to be years, and then the number of students is going to be Y. All right, write an equation for each situation in terms of T and determine after how many years T, the number of students in both high schools will be the same. So I'm looking for where they intersect, where they're the same. So I'm just going to zoom out until I find it. All right, and is there a all right, the faster way instead of me searching, but I did find it real quick. It's right, well, is it right there? Nah, okay, so the faster way would be to put them equal to each other. So I'm going to do that because I think I'm going to be searching forever if I don't. So they're going to be equal to each other. Let's see what it says. We only support X and Y. Okay, so I'm going to change it to X so I can see, and X so I can see. I'm going to hide this, and we're equal to each other. And I'm just going to double check at 5 is what it's saying. But I'm going to double check that. So putting these back, if I go to 5, which is over here, I'm going to zoom out. So, man. I'm going to go up here, and I'm looking for 5. There's 5 right there. So I might have passed the intersection. I'm just going to make sure. Yeah, it looks like it's getting closer and closer, and looks like, yep, right at 5. So let's see if it'll let me click it. Yep, right at 5. Okay, so you can just put them equal to each other, and where it crosses the x-axis will be what it is, and then you can double check that that's where it crosses by going to that number on both. So this is going to be 5 years, 900 students is our other answer. So now we can answer the question. So write an equation. So this is going to be 7t plus 550, and this is going to be 50t plus 650, and the answer to, let's see, determine how many years the number of students in both high schools is the same. So the number of students is 900, they're the same. How many years is that going to take? 5 years. So this is going to be 5 years. And I'm going to look for years. Perfect. Okay, so that's what you're repeating over and over again for each one. So we're going to do, I don't know which one I haven't done. I think I haven't done this one. So this one's compare y values given an x value. Francisco and Logan are reading the same book at the beginning of the month. So my initial, Francisco will be on page 43. And Logan will be on page 16. So those are my initial values. Francisco will read 8 pages per day. So that's the one that keeps happening. So that's going to be the 8x positive because it's adding 8 pages. Logan will read 11 pages per day. So that's going to be 11x. Let F represent the page of the book that Francisco is at the end of T days. Okay, so they're telling me do not use X, make sure you use T. Into the month, and let L, so I need to say L, which is what I chose, the page of the book where Logan is at the end of T days. So again, we're not using X, but T. Write an equation, so I did that, in terms of T, and determine whether Francisco or Logan is further away after 11 days. So this is my equation, and I need to know where we are at day 11. Error creating table. Why? Okay, I think I just need to refresh my my calculator, so give me a second. All right, so it's still telling me error, so I'm going to try changing this to y and x and see if it'll work. Okay, so it can create with f and l, you have to be y and x. So just remember the first one is f and the second one is l. Let me change this to y and x. Right, and then we have our table, and we're looking for what number? 11 days. So we can press enter, 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 or we can just type in 11 on both people. Okay, so now we're ready to write it out. So F was the first one, which is 8, not X, but T. All right, they wanted in function notation. And then the second one was 11x plus 17, but not X, but T plus 16. All right, and then someone will be further. Okay, so at 11 days, this is Francisco, is at 131. 11 days is at 137. Okay, so Logan is further. So Logan will be how many pages further? So 137 and 131. He will be 6 pages further along in the book than Francisco after 11 days. So this one, not only do you need to write the equation, but you need to evaluate it so you can compare it. All right, last one. Determine the interval where one function is greater. Braden is deciding between 2 different movie streaming sites to ascribe to. Plan A, and I'm guessing Plan B. Cost $18 a month. So again, per month, that means that's my slope. So equals 8x. Oh, it's 18. Make sure you're careful to read. So 18 per month plus $2 per movie watched. Okay, so, all right, so plus $2 per movie watched. So this sounds like this is my slope, but it's not. So this is $2 every movie plus $18 every month. Okay, so what it means is in 1 month, the number that's going to keep changing is not 18 because that's 1 month. But within that 1 month, if I watch 1 movie, 2 movies, 3 movies, 4 movies, that's the one that keeps changing. So again, they're both per. So if that's how you remember both, that's not going to work because they're both per in this question. All right, Plan B. All right, it costs $30 a month, so that's my starting fee every month. And then it's $1 every movie, so 1x. Okay, so again, every movie is $1, so I can watch 50 movies inside 1 month. All right, let A represent the monthly cost of plan A if Braden watches X, so this one is X, and B represent the monthly cost of plan B if Braden watches X movies per month. Write an equation for the situation and determine which interval of movies watched for which plan is cheaper than the other plan. All right, so obviously I can't have 0 movies, right? Yeah, obviously I can't have 0 movies. So anything after 0, this plan is cheaper, whatever purple is cheaper up to 12 movies. So purple is cheaper after 12. After 12, black is cheaper. That's what we're looking for. So what's purple? Purple is plan A. So plan A is cheaper up to 12 movies. Then after that, B is cheaper. So let's go ahead and write all that out. So 2x plus 18. This time they wanted the x plus 30. All right, so plan A is cheaper than plan B when x is less than, so wait, plan A. Plan A is cheaper. Yes, this is cheaper than this one. All right, when x is less than 12 movies. Okay, so this is 12 movies. X is 12 movies. Okay, and then after 12 movies, this plan is more expensive. Okay, I'm just going to do one more of those because that might have been a little bit confusing. A small town. Wait, this might not be the one. Hold on. All right. At the beginning of the year, Juan had 20 in the bank. So that's my initial. So I'm going to say Juan J had $20 in the bank. Then he's going to add or subtract every time. All right. He saved an additional 17. So that's the one he keeps adding on to that. So positive 17 because he's saving. Nakisha started, so N, started the year with $100. So her initial, her y-intercept is 100. And then what does she save? 9 every week. So I'm adding 9 to that amount every week. So those are my 2 equations. Let J represent the amount of money in T weeks. So this time you're going to make that T. And this is going to be T as well. Saved in 2 weeks after the beginning of the year. Write an equation for each situation in terms of T and determine the interval of time. All right, so this is, and again, I'm just going to write it here so that you know this is T weeks. And then my Y value is my dollar saved, my total amount saved. All right, so write in the functions. I've got 17T plus 20 for J. And for N, I got 9T plus 100. And now I need to know one has more savings in Nakisha. So J is blue. Okay, blue. So I'm going to zoom out. All right, so this is the bottom line. So this is after, like if I pick a number, let's pick this number right here. After 4.272 weeks, blue has $100, but at 0 weeks, green has $100. So this one is less than green until 10. So until 10 is the number. So this is the number of weeks, and then this is the amount saved. Okay. So when it's less than 10, blue is less. So 1 is less. So 1 has more savings than Nakisha when. Okay, so he's looking for more. So when is blue above the green line? After 10. So this will be when T is greater than 10, then 1 has more savings when after 10 what? 10 weeks. 10 weeks. Okay, so this one you kind of have to read a little bit and just be careful in what you're choosing. Let's practice.